So this one's going to be a live broadcast, and I'm continuing on from a video that I did earlier. So, and what I'm going to do is actually I'm going to post the link if I can get the link somewhere. Let's have a little refresh. I'm going to post it into Twitter or somewhere just so that others maybe other people will join. So get shareable link, and I'm just literally going to post that into Twitter, literally just like this. So maybe other people will be joining on this link. But what we're going to go through, and it's going to take, there's about 19 questions here in this little section, which is Python interview questions for experienced, and it probably actually means for experienced users. Are questions that are most likely or are likely or possible to come up. And I've not seen some of these questions, so I kind of read through the first 2 or 3 of them. I have a little handle on what they might be, and then afterwards I've not read this question, although I can see explain, split, and join. I kind of could be able to mention what they are. Also, what does star args and kwargs mean? So args and kwargs is what they're often called. What are negative indexes and why are they used? Okay, fine. It looks like it's okay. There's 19 questions. I'm going to try not to be more than an hour, but that's why I've done it as a live stream, because some of the videos are like an hour long or more. And I'm just going to go through it. If I am an R, then it's because, I guess, basically because I'm not sure of certain things. I'm also at the same time trying to, I wonder if I can go to the live stream in some way. Customization, I'm just clicking on the live stream. If I can. I don't want to do the YouTube. I'm not sure of certain things because I get background on that one. So let's have a little browse. Customization, no. Analytics. Maybe if I actually just click on, hold on one sec, what's that? Viewing live control room. Okay, I'm just viewing it in live control room just in case anyone does join, and I'm going to put a little test message in. Test. In case anyone does join from the Twitter post. I don't have that many followers. Oh, by the way, if you could like and follow, because I always leave this till the end, an hour into the session or 2 hours, but if you could like and follow the channel, that'd be really, really helpful. Also, if there's questions that you have afterwards that you want to post, or comments or anything like that, and things and errors that I make, I'm invariably going to make errors in this because everything that I'm going to be doing now is kind of effectively live. But if there's anything like that you want to do, definitely post your comments, likes, feedback, even if it's to tell me that the font's too small or something like that. It's always very useful. And yeah, just do hit the like button. It's really helpful. That'd be quite useful because it means I can continue doing this. And yeah, and with that, we'll crack on. So the first thing I might do is actually zoom in if I can. So let's try and zoom in. There we go. So Python interview questions for experienced users, and the first question that pops up is, how is memory managed in Python? So I'll try not to be too long on some of these to get through in the hour. So we'll read through it a little bit, but memory management in Python is handled in the Python memory manager. Now, okay, memory is handled in different ways in different languages, so it's a little bit pertinent to Python as to why it's done. But basically, all types of memory goes into something called this heap. Here it's called the private heap space. Over there, this memory manager in Python. So when we create a variable, anything, it needs to go into memory. And I might bring up something like, where is it? I've got my VS Code here, and if I zoom in on that, I had a lot of code running from a previous session. In fact, maybe I'll cancel some of that out because we might start again a lot of it. Let me plus again, and I'll clear everything that was previous. But basically, if we take a variable x and we say it's equal to the value of 10, one thing that we can do is we can actually where x exists in the memory, so we can do print of, and instead of doing print just of x, we can do print of x, but let's do, that will give us the value 10. We can do print, and we can use this id function here, and when I go over the id function, it returns the identity of an object, so id of x there, and when we run this, F5 to run it, we get our value back 10, and then we get this other value back here. Now this is, you know, some kind of it looks effectively like a random number nearly. I wonder if I run it again, if I get a different thing with it, because it's like rerunning the code. Possibly will. No, it didn't. But one way or another, it doesn't matter. But what this is this is a unique number which is pointing to a space somewhere in the memory, and basically every variable that we create, and this goes, you know, is kind of like true for every language, it needs to be stored somewhere in the memory, in the random access memory. So you know, that's Python's way of doing it. So it goes into this like stack, or this heap effectively, and it says here all Python objects are stored in this heap, and being private is inaccessible to the programmer. That's kind of like is and isn't true, though Python does provide some cool API. Additionally, Python has built-in garbage collection, and this is kind of like a bit more of the important thing. All of these things go into memory, whatever we create. So we could have created a second variable y equals 20, right? And then we could have done the same thing, which is print id of and then y, and we can run our little piece of code. And we notice that we get two different memory addresses here. This one ends, they look very similar actually in the beginning, 140729 all the way up to about here. And then this one says 536 and this one says 856. So they're different numbers. And one interesting thing, I believe, is that if we set z equals to 20, and we can do print of z, just like that, and hit F5 to run it, note how this memory and this memory address, or these unique identifying numbers, are exactly the same. So x, also y is the same as z, and x is different, and that's because these two things are of value 20, and they're actually pointing to the same space in memory. So imagine that the 20 is kind of, the 10 is over here at the top, so that's 10. And the 20 is down here, just like that, so that's 20. X and Y, also Y and Z, are both pointing to 20, and if I change the pen color there, X is pointing to, in fact, you know, there we go, that's X is pointing to 10, and let's get a different color there, we'll continue on, but Y and Z are both pointing to 20, so it's actually saving, it's actually quite clever. Python's saving a little bit of like space as it was, because these both have the same value, and this value of 20, even though my 20 doesn't look very well written, this value of 20 over here is referenced by both of these variables. And also, when these variables are no longer used, so I wonder if we can do that as well as the example. So if I put this into a function, def, so if it's a define a function, we won't return anything there, so I'll just get rid of the return, and we'll put everything into the function tab. If we're outside of the function, we do print id of x. Well, already we sort of like get the hinting of it, but x doesn't exist, it's out of scope, and basically this memory is destroyed thereafter because Python's got no purpose for it, and that's the garbage collection part of it. So that's kind of like, that addresses the first question: how is memory managed in Python? Everything goes into a stack, and you know, this private heap space, and then also we have some sort of garbage collection for things that are no longer used, and then that's done with something called the reference counter. So it goes along and literally counts references to an item and says, you know, are we using X? That's got one reference. Are we using it again? Well, that's got two. That's got three. But the minute that we remove all of our references to X, it's no longer needed, and the garbage collection is done. So memory is handled. We never had to, as users in Python, to deallocate memory. So that's one of the niceties of Python, by the way, is it has this garbage collection. Other languages, some of the other modern languages also have garbage collection too, and some of the older languages don't have the garbage collection, so you have to go and deallocate. You have to memory allocate and memory deallocate for your memory in your language. Anyway, we move on to the next one, which is what are Python namespaces, and in a way we kind of like began to cover it in the previous video as well, but actually here, the picture, I guess the picture covers it slightly better, and actually the acronym is often known as I think it's LEGB, local, enclosed, global, and built-in. But here it's BGEL. It's going the other way around. But it doesn't matter. What actually happens is the local is mostly at the function. Maybe I'll do a little read and then we'll do a little write-up of it. So a namespace in Python ensures that object names in a program are unique and can be used without any conflict. So that's kind of like the important thing, is that we don't want to accidentally overwrite something because we had one function and then we had another function and they were both referring to the same thing, and when we ran our second function it ran the variable in the first function. So we don't want to be doing something like that. So that's what the concept of namespaces does. So Python implements these namespaces as dictionaries with the name as the key mapped to a corresponding object as the value. This allows for multiple namespaces to use the same name and to map it in a simple object. But anyway, let's just debunk some of that. So the first thing to debunk is, I guess, the dictionary. So again, I'm going to go back here. What it's talking about is we might have a dictionary, and a dictionary looks like this in Python, which is a key and a value. So, but in our particular case, the value might be an object. So y equals there we go. So we got a key and we got a value. Our value could even be a variable like this, but it's a whole bunch of key value pairs. So like key one, and then we might have more keys in there. So we'd have, for example, common return key 2. They're going to be uniquely named, and this might be like 100. And then paste that again. We can have key 3 over here, and this could be y. But we get the point that we have something in, and we can call our object now. So we could print b. So we'll just have a look at what it looks like. That was the autocomplete going off, or the snippets at least that I've got in there going off. But we get this. It's an object, and this key 1 refers to a value. This key 2 refers to another value, and this key 3 refers to another value. And our key and the object that's referred to in key 1 is actually a variable, and this variable is pointing to the integer number 10. Here key 2 is literally just pointing to the integer, or the object is actually an integer there. And finally key 3 is pointing to a list. We could put anything in as these objects. So going back anyway, our namespace, well, our functions kind of like have the same sort of thing. So when we created this function over here, now everything is in the namespace as it was, and it's in the namespace of this function. So I'll just call it like my, I don't know, what was our first section actually called there? We'll call it my memory. Right, there we go. So we've got this function and we've called it my memory, and everything's kind of like enclosed in that. So that's one namespace, and it's all done in Python. Just for remembering, it's all done by the indentation. Here's the indentation over here. That's the end of the code because we've come out of the block of the code. So that's basically how it looks for Python. Now, over here, I wonder if we can print, well, one thing that we can do is we can print my memory, and if we were to do that, we'll get this function is actually also, it's actually pointing to another, like it's a mapping somewhere to a piece of memory on our code. So when we do that, we see we've got this function. So we've got this function memory, and it's at this kind of like location. But let's do something else. I think we can do dict, because that normally contains everything. So if I hit F5 to run it, or code, oh, it gives us a blank dict. I wonder if it'd probably be better with classes actually in order to show it. I wonder if I can create a class straight off the bat. Class within it. We've got a my class here, and my class we can see all of the key value pairs here. So like we've got in the my class thing here, so function my class, we've printed it. We've printed the dictionary of it. We can see a whole bunch of stuff. So the module is in main. The document. Okay, so it says description of the class. That's a doc. That's the doc of this. So these are all like private functions. Somewhere here, I reckon. I wonder if we do have it, because I should have had self.a maybe somewhere in there. But the point being is that this is all a dictionary. This is how Python stores stuff. So the local our namespaces will contain these dictionaries of things, and so we've got these different types of these types of namespaces, and the first one is this local one, and local refers to like the most inner one, if that's the best way of describing it. So right now this is local, but we could actually wrap this my memory into another function. So we could do like the outer function, so something like that, and then we could wrap everything into this function. So now in order to access my memory, we've actually had to access the outer function first, and we could actually even have some code that goes before this. So like print the outer function. So that's what actually would happen, and inside actually here we could even sort of like print the inner, or I'll call it the local function. So now in terms of where we are, if you can imagine, the indentation is sort of like the blocks and the nesting of it, or how it looks. We've got a function inside a function. So we've got this whole function here that is nested inside of this much bigger function on the outside over here. That's effectively what we have. So we've got a function inside a function, and that's the reference to, let's get this arrow to the right thing, that's the reference to this nesting. So the inner one is local, and the next one is enclosed. And then outside of that, we can have other pieces of code here. So we could have like x equals 1000 over here. Now, if we do print of x, like what are we going to get? And actually, we've already got an x defined outside already. We've got x equals 10. So yeah, I can remove this one. If we do a print of x over here, what are we going to get? Print x. Because we set our value of x over here to be, so let's make them two different things. So let's make this one 99. We've got these two, which value of x is going to be taken and why, and that's the purpose of the scoping, because these two x's are no longer confused with each other. And in fact, even in the class here, we could make another variable over here. In fact, we can make it an attribute, so we could say x equals 10 here, or x equals 1. We'll make it completely different, and this x, again, will not be confused with the other x's. So we can see that they live in different parts of the code and they absolutely won't conflict. So when I do print x here, I am absolutely sure what I'm going to get. I'm going to get I'm going to get this 99 over here from line number 20. And where this print statement was on line number 16, if we were to call the myMemory function, so I'd now need to call it, and in fact I have to call it from inside the outer function. So I'd have to go here and kind of like myMemory. Now I can call it. It will start printing out all of these IDs and things again at the where it got called. So I'd actually, in order for that to be called, I actually have to call the outer function. So I'd have to call the outer function here. So outer function. And I think I probably need to scroll up a bit on it, but yeah, we've got our outer function, and then we've got a 10 over here, and that was the 10 that was related. So this value of 10 came from here. That was this x over here. Well, the print of x, which is this version over here, manifested itself down here. So, and the other value of x was elsewhere. And finally, like, just going over to here, so our enclosed version as well, so our locals and enclosed, we've got another x that existed here, which is my class. And how do we access this? Well, I'd have to do something like c equals my class, and then c dot, and then we can see we've got this other x that comes out here. I might want to print that out. Print c.x, and that's the last thing there. And remember, we set it to the value of 1. So we've got 3 different values of x's, and we know exactly where they are. There's no naming conflicts, there's no overwriting, there's none of that. So, oh, hold on, I made that mistake before, like 10, I'll stick that in there. Because basically in my class, just the default setup is what happens is it pulls it, it's expecting one argument to go in there, so I just stuck an argument in there for the sake of it. So F5 just to run it again. And there we go, we've got our different values of x. We've got one value of x here, which is 10. Then we've got a second value of x, 99, and our third value of x, 1. So that kind of like covers the local, enclosed, global. And finally, built-in. What's built-in? These are like the modules that come shipped with Python. So, and also like we could create our own modules as well, and they will be, and all of the methods and attributes in any particular module are they're also like scoped to that module. So that's kind of like, I guess, that they live inside that namespace effectively. So these two questions are kind of like similar. What is scope resolution in Python? They're sort of like very similar. So we kind of like get onto that anyway. So maybe I will sort of like move on to it. So we've got these built-ins, and the built-ins are going to come. And the reason I say we're going to get onto it is because I see math here already. So we could do import. We're importing a module from somewhere, and Python, I think it comes shipped with about, I don't know, 14, 50 modules already, math. And that's before, like, then there's hundreds and hundreds of them. In fact, I think there's thousands of modules that you can import externally. But import math, and now everything in this math module, math dot, is all enclosed inside this math module. So we can get all of these functions that were written inside the math module. And I guess if I did pull it up, it would look something like this. If I go to the import of math, I wonder if somewhere in SW3 schools, the Python documentation will have it. You know, it goes through. So this is like our math. This is the math module, like what it contains, and it's got all of these functions that are in it, and the description, and maybe some utilization of how you can use these things. And they're all math related things, so they all belong in the math module, the collection of things that are together. So you can find an exponential, you can find a cube root. They're all very similar things. So we just go back. That's basically it, and that's now, so math.py is an easy one to do. We can say p equals math.py. So that's pretty much it. That covers all of the well, it doesn't cover everything, but it sort of like describes at least the beginnings of what built-in modules are as well, and we understand where that the same named variable can lie in different namespaces without conflicting. Now we could, if we wanted to, we could choose to share the namespaces. So somewhere in here, we could make this, we could share it with the keyword global. So we could say like global X. Now we've got to be a bit more careful because this X might be sharing with this X that's outside of its scope. So this was in a local scope. This was like enclosed. And then here's our global scope. And we've just said make X global. So Python gives us that functionality as well, because there are rare cases where we want to use it, but by and large it's kind of like frowned upon, because you really want to know what your variables are. So, and if you do this global, then you've just got to be careful. It opens you up to errors, which is why it's frowned upon. But yet a functionality is provided for doing it. So that kind of like covers all of that. Now we go on to what is scope for resolution in Python. So it's kind of like synonymous in a way with the namespace. Some objects with the same scope have the same name, but function differently. Okay. In such cases, scope resolution comes into play in Python automatically. A few examples are, okay, Python modules, namely math and cmath, have a lot of functions that are common to them. To resolve this ambiguity, it's necessary to prefix them with their module like this. So, we had the math module up here, somewhere at the beginning. But I believe there's another module, import cmath. And, I've imported pi over here. Now, I don't know if pi exists in cmath, but one of the things that I could do was I could have done from math import pi. Right. Now, I didn't have to set p equals math.pi anymore. I could have just literally done p equals pi. And that would have been perfectly fine, because now we've kind of like brought it in here. Now, I don't know if cmath has a function called pi as well, but we can do from cmath. We can have a look and see if it does. Import pi. It did. Or did it? Hold on. P, let's have a look. Yes, it does, because we can see it in the drop-down list. So, now, pi is going to have the same value both times. But imagine that they didn't. We've now got two identical functions kind of like named. So the better way of doing it, quite often, unless you want something specifically that's very unique and you're going to do it that way, one way of avoiding this naming conflict is we could have p1 equals math.pi and then p2 equals and then cmath.pi. Right. And then we could, if we wanted to, I'm just going to comment these things out so we don't get too much stuff in terms of what comes in our print statements down below, but we could print P1 and we could also print, and the reason I'm printing them directly above each other is I'm presuming that they are exactly identical to all decimal places, but you never know. So let's just have a look at our values of pi somewhere, wherever they've come in. I'm going to get rid of some extra stuff as well. Where is my values of pi? There we go. Yeah, they're exactly identical. But if they weren't identical, we might accidentally conflict and overwrite one with the other if we did do it this way. So we can't like, sometimes we want to do it this way because we're very clear and we won't want to only extract one thing from the math module, and we know that we're not using anything else. We only want pi, so we don't need to import the whole math module and do it this way. So we wouldn't need to do it this way. We could then just do it that way. So it swings and roundabouts. We've got flexibility to do both. But if we do want to avoid naming conflicts for large pieces of code in particular, where you've got lots of variables flying around, we would do it that way. So that's kind of like, that's the scope. And also these things are now pointing to two completely different modules. One is pointing to, this math module, whatever it is over here. That's all of the math stuff. So that's all of the math stuff over here, and then we can imagine that we had another module over here, which is CMath. So CMath. Ignore the really childish spelling, but this one here is literally pointing over here. So there's no like conflict, and this one is pointing over here. There's two completely different things basically, and there's no conflict of the naming. Pi could exist happily in both of them and be different values in both of them, and that wouldn't be an issue, and that's true for all of the functions out there. So we've got that one covered then, I believe. Let's move on. We've got, consider the code below. An object that's temporarily initialized to 10 globally, and then on the function call, it's the same kind of thing as we've gone through, so I think that's fine. I think we've covered it. Now, here again, and correctly so, it's mentioned this behavior can be overridden with the global keyword inside the function as shown. So if we wanted this temperature inside of our function to actually affect the temperature outside of our function in what's called the global scope, then inside of our function we just need to put global temp, and that's saying now link them effectively. Also, I believe, if we were just literally calling temp and we didn't have global, then it would maybe pull it out if it wasn't defined, but the minute we define it, it's now in the local scope. And that's basically it. So this namespace, the concept of namespace and the concept of scope is this like segregation so that we don't have conflicts in naming, basically. Right, shall we move on? Number 22, I hope I'm relatively fastish on this. Nope, I'm slow. What are decorators in Python? So that's the next thing. I'm not a fan of decorators, and I've heard of them as being called syntactic sugar, which is really long mouthful of complex words. Basically, they're not wholly necessary, as in we can get by without having decorators, but they're a convenience that have become commonplace in Python because of their level of convenience. But what we've already seen in a way that we can nest a function inside of another function. So we've got this outer function here, and we had this function which we called myMemory as an inner function over here. Now, imagine that our outer function did some other operations other than just sort of printed at the outer function. And one thing that I might want to do, for example, is I might want to time how long it takes for this inner function to work. So I might get an outer function and wrap it around the inner function effectively. So what I could do, just as a sort of crude example, is import another module, popular one, time. Okay, and over here I'll do t1 equals time dot time. That's before this function is run. Then we might want to run our function, so we could do the myMemory thing over here. We could run our function, and then after that function is run, or in fact we define the function, we don't even have to do it there. We could actually have, let's just move it down the code. I'm just pressing Alt and the down arrow in the VS Code. That moves lines up and down. It's quite convenient. We can have t2 equals time.time like that. Now, and then we could have something like print the time taken is colon and then t2 minus t1. So something like that. I wonder if we can actually do this, which is, I could round it to a couple of decimal places. 2f, I wonder if I can do that. No, it doesn't let me do that. Okay. Maybe something like this. We'll just round it off to 2 decimal places, right? Now, we can start passing any function into this outer function, and in fact not even have our memory, but whatever, so we can have some sort of function here. So we can have some sort of function here, and then this function, when we call the outer function, it will run our inner function. So let's even take the memory one out of here for now. It might just run our function here, so func, right? And I'm going to do this, which is import another thing, which is typing, which is it typing? I'm sure that's for the type hinting, which is, I'm actually going to do this from typing import callable. There we go, because we want to tell our thing that this is actually a callable object. There we go. So now what we're calling here is this function over here, like that. And we could then time our function that way. So what we could then do is, when we do run our outer function over here, we could have had another function that we pass into that function. And that's the purpose of this decorator. It's sort of like replacing that pattern. But we see that we could do that pattern. That was perfectly fine. So let me just do it for the sake of doing it, although we did have a worked example. So let's make another function, def add numbers, right? There we go, A and B, so something like that. And then return A plus B. So our outer function now, when we do call it, if we do the brackets, is now expecting a function to be put into it. So we could have like add underscore numbers that goes into it, something like that, and it will work. What I'm actually going to do, I think, for the purpose of attempting to get it completely right without getting it wrong, let's have a look. Is this one? I'm wondering which one is the better piece of code to go through. But I guess one thing that I want to highlight at least is this bit here, which is what I was saying they're not necessary, is this part, which is the beauty of decorators lies in the fact that besides adding functionality to the output of the method, they can even accept arguments. And actually the thing that I had, my function, required some arguments to go in there, and can further modify those arguments before passing them into the function themselves. The inner nested function, i.e. the wrapper function, plays a significant role here. Is it implemented to enforce encapsulation? So this is all this stuff about scope and so forth, that one function lives inside of another function. So let's actually just take this piece of code here for the sake of it, copy that, and I might comment everything else because there's a lot of stuff that's now in there. So let's sort of get rid of Control/everything, and let's paste this little snippet of code in here. And I want to break this up a little bit so that it's clear here. We've got something, it's called, we called it our lowercase decorator, which takes in a function, right? This function then is called, it looks like it's called in the wrapper function over here. So we've got this wrapper function, and then it goes along and makes everything lowercase. That's what it does. And then it returns this lowercase, and then we can return back the wrapper function. So that's kind of like how it's used. And let me just split this one out as well, because this one here has got a splitter, which also it takes in a function, and then it calls this function and does function.split on it. So and we can, not only can you decorate once, but you can decorate multiple times. So you can add this functionality onto existing functions already. And let's have a look here. Yeah, I mean, I guess that should it's going to split hello and world. We already see what the output's going to be like, so there's not much extra I can add on that. I was going to hit I wonder if I just have to get where is hello on here. We run hello and that returns hello world. I wonder if I have to do a print of hello there, or I'll just do r for result equals hello and then do print of r, so something like that. I wonder if that will spit out the actual numbers that we want to get. Yes, it does. So the split function, so what's actually happened is we've wrapped this particular function, this hello world, with these other two functions, and the first thing that's happened is it's split, and the second thing that's happened is it's turned this uppercase h and this uppercase w into lowercase. So we split it out, put it, and therefore created a list with two items in it, index number 0 and index number 1, this hello and this world, and it's also lowercase them. So that's kind of that sort of like covers yeah, well, it pretty much covers nearly all of encapsulation. Now the only slight difference here is if I was to take this one over here, get the quotation bit in as well, and kind of let's just comment all of this out again and paste over here. Is one other thing is if our wrapper function had some arguments that went into it, and again I should really separate these out so we can see it nice and clearly. The code looks like that. Here's our decorator function, and this is the decorator function that's going to capitalize the names, and here's our wrapper function that's nested inside the decorating function, and it's going to take in two arguments. So we take in our function, so say hello, which is being decorated by the decorator function, so it goes into the function here, and we want to pass in these two arguments as well, which is name1 and name2. That's what needs to go in here, and they'll feed into here, and then we're going to capitalize both of the names. And I guess again, if when we do this, that we want to do like r equals say hello, because we want to actually print it out, to see it print r like that. And F5, and I believe they're both going to get capitalized basically. And I guess more importantly, maybe we could do lower. There we go. So let's just change the functionality on both of them, and this one could be something like that. The first argument is going to be capitalized, the second argument is going to be lowercase, and I believe it would work like that. And it does. There we go. We see Darren gets lowercase as well. So, and also we did extra things to it, whatever we wanted to on here. And what did we want to do on here? It didn't affect this function other than what happened on the decorators. So we got this hello and our Sarah, and that was capitalized. So Sarah got capitalized, and then we had a hello over here, and that was Darren. But notice our Darren came in like this, like all funny letters up. Okay. And when it was wrapped with this decorator, it then fell in because it was argument number 2, and it got lowercase. So that's basically decorators, and that's kind of like a very complete sort of form of what decorators do and why they're quite handy. So you could use wrapper they're glorified wrapper functions. There we go. It's better than calling it syntactic sugar. Glorified wrapper functions. So, and I think the first time I came across decorators actually is actually in Python. I'm not sure. I don't know if the concept existed anywhere else. So it's okay having functions in functions. But yeah, you know, if you're going to do it often, or you want to add functionality somewhere, then a decorator is a very useful and convenient way of doing it. So the next thing is number 23, and this is unique to Python actually, which is not the first bit because dicts aren't unique to Python. A dict is a hash table in other languages quite often, but this concept of the list comprehension, which is quite nice. And here we go. Python comprehensions, like decorators, are syntactic sugar. Well, that's not wholly true, but it is true to an extent because I believe that list comprehensions are actually about 25% faster than for loops, which is what they replace. So, but to an extent, they're syntactic sugar. They're used in certain cases. If you've got something that's relatively small that you want to do in quite like visual, it lets you write it in a way that you might write the English language, which is for x for x in something if something. Whereas with a for loop, you'd do your you'd run your for loop. You'd declare a list before, and then you'd run your for loop, and then you would populate it and do all of whatever you needed to do and keep on appending the list. Well, a list comprehension saves you creating a redundant list in the first place and then appending it. It kind of like does it all in one go, which is quite nice. So I wonder if this is, you know, let's just take this as an example. So let's get rid of all of this stuff over here. We'll get rid of our decorators, // and we'll go down to the list comprehension examples here. So we've got this my list over here, and then we've got this squared list, right? And let's just print squared. Oop. So we're just going to print squared list like that over here. And so we got 2, 3, 5, 7, and 11. And if we're going to square the numbers, it's going to be 4, 9, 25, 49, and 121. And look how it's written. X squared for X in my list. So kind of like a neat, tidy way. It's taking every value of X in the list and it's squaring it and it's spitting back an answer quite conveniently. Now, the reason why I just wanted to do the first one on its own is just to be clear, right? We could actually have set like squared, again, squared list, and we could set it to this empty object, and then we could do this for loop for sometimes I don't want the autocomplete, for I in my underscore list. So we've created this like placeholder variable anyway for I in my list, and then we could do something like squared list dot append, okay, and then we could append it with I squared like that, and we could delete that. So we can see now that this one line over here has actually constructed the squared list. So that's one line of code, and it's also dealt with the append and effectively the x squared, or the I squared in our case. Let's change it to x so it looks nearly identical. Here we go. So it's performed quite a lot of useful stuff. It's done it's automatically done the list for you, and then it's automatically done the appends for you. And then we could print this again. So look, we can literally take it again, you know, prove to ourselves that they're exactly the same thing. And there we go, they are exactly the same. Here's our first version, that was from our list comprehension, and this was from our for loop. But what we can see is straight away, imagine that we could take all of this stuff here and dump it straight into the square bracket. So like we could X all of this out and so like stick it all into the square bracket somehow. That's effectively what it's doing. And it's actually doing it like this, which is it's taking this part out, this append, and it's taking the x squared for x in my list. Now it's saying, well, we don't need all of this. There we go. We don't need the append. Now look what's happened. They're exactly the same. So this list comprehension has now been transformed into a for loop. Now, the for loop has now been transformed into list comprehension, as in that they're now exactly the same. They contained all of the same variables and they behave in the same way. We could get more complicated with list comprehensions than that. So you can do conditional filtering, right? So we can get a little bit more elaborate, which is if we are to take this x squared for x in my list, and then if x is greater than 5. There we go. So something like that. So now it's going to only square numbers that are greater than 5. So 5 isn't greater than 5, so it's only going to give us back 49 and 121. And these other three numbers are now going to be the original numbers. So if we run this, F5 just to run it, we've got this 49 and this 121. I actually said we get these numbers back as well. But no, what's actually going to happen is it's going to ignore these first three because they're not greater than 5, and it's just going to give us back the squares for them. So it's done a filtering as well. So we can do even cleverer and more powerful stuff. And just like we can do a list comprehension, we can do a comprehension on any collection type because it's an iterable. So or a sequence. The words. I'm not sure which is like the most popular or correct word, but is it an iterable, which means you can iterate through it. I often call it an iterable. I see it quite often being called a sequence. But one way or another, you're traversing the sequence or iterating through the iterable. So here we can do the same thing for the dictionary. And if we were to, so that's called a dictionary comprehension as opposed to a list comprehension. And we could, I guess, print the square dict. And what was our original dictionary? Okay, fine, it was putting everything into a dictionary. And that's quite nice, actually, because what's actually happening is we're going to get x. So we're going to get our original list value. And then we're going to get its squared value back. So look, 11 gave us 121, 2 gave us... I think notice one thing to note about the dictionary is it doesn't necessarily do it sequentially. It just does it in, I think, whatever order it will do it in. I wonder how it will come back. No, it's done it in order this time. So 2 gave us 4, 3 gave us 9, 5 squared is 25, 7 squared is 49, and so forth. So it's given us back the key value pairs quite nice as well. So that's a dict comprehension. So we've got list comprehension, dict comprehension. That's what they are in Python anyway. What are dict and list comprehensions? I'm not sure why it says here, for example, combining multiple lists into one. That's a bit interesting. Hold on. Question that has come in. Do ID var show the address stored that variable? This is a question that's come in, which is, if I just stick it into here so that it's more visible, basically is does it show the address stored in that variable? Well, it's not actually. It is showing the address, but in a. So if I do this ID keyword over here, it's like I don't even have to hover over it. It says. It returns the identity of the object, and it says importantly here, this is guaranteed to be unique among simultaneously existing objects. So it's Python's version, Python's like neater interpretation of the CPython, because the CPython uses the object's memory address. Really, I think the address is some sort of hexadecimal thing like 0x something something something, but you can convert that into a clean looking integer. So it's Python's version of that. So the answer is yes is the answer to that question. So so it's a good question, by the way. I think there is a way of also converting it like to hex. I wonder actually if I can do something like let's just do x equals 10, and then over here id of x, and then hex. No, it won't be like that. Maybe I can get the hex of it. Yeah, I can. So we can print over here, we just print id of x, but then we can also print the hex of that. So we can sit print. So when we run that, oh no, it didn't give a, what I was expecting to get. So this is the ID, and I think this was a hex. I was expecting, maybe it's not hex, and in that case, but it's an integer that is pointing to a space in the memory that is unique. So it's definitely doing that. So if two variables are pointing to the same value, they're going to have the same address. That's how Python deals with it. So in its cute way, which is quite nice when you get used to it. Now, just continuing on, because it said here, perform conditional filtering operation. Okay, so we've talked about that, and that's quite useful in the list comprehension. Combining multiple lists in one. Oh yeah, okay, fine. So that's true as well, because you can do that you can do it all in one thing. So instead of doing creating a for loop. So imagine you've got these two things here, like that. And let me just get rid of these, like that. Comment it out, and maybe I'll comment the rest out too. Imagine that we wanted to join these up, so we could do something like for I in range, and then sort of like the length of A, right? Because A is going to be a certain length long, and then we could do something like, we'll create this new list here, which is C, which is this blank list, and then we could do C dot append. And then over here we could sort of like, I don't know, put in the tuple of A indexed at I, and then comma B indexed at I. Now that's kind of like, I don't know if it's overcomplicated or we couldn't understand it. It's kind of like still in one thing, but we've noticed here, and this is the giveaway for the list comprehension, is we've declared this empty list in preparation for putting things in the list by appending the list, and it's a very common process. So I'm hoping that this will work actually. Let's just do a print of, I'm doing this all live, so if it goes wrong it's because I'm doing it live, and then I'll have to pull out one of the Google Bars or ChatGPTs. If I do that, yeah, I did that, okay, but let's have a look. Built-in function, it's not subscriptable. Let's have a look. Hold on, I've used append incorrectly because I've done append with the square brackets, and I didn't want to do that. I wanted to append like that. There we go. So that's a fundamental mistake. Let's try and run that again. There might be another mistake in it, but let's have a look. No, it worked. So I've managed to kind of like zip these things up together. So I've combined the 1 with the 7, the 2 with the 8, and the 3 with the 9. Fantastic. I could do that, and I could do it like that. And I could even get away with doing that as a one-liner, right? But what's shown down here is we can do this. We can do one of these, which is parallel iterators or nested iterators. I prefer this one because I don't like to use a zip function. I don't like to use functions sometimes where we can get away without it. So let's just do this one, which is the same thing. So we'll print out RC, we'll still get that, which is this, and we'll say that C is equal to this. And okay, I needed to use X and Y. So let me stick in an X and A. I used them. Did I take their ones out? A and B. I know that might be fine actually. Oh yeah, it's fine because that comes later. So we've got X, Y for X in A, for Y, for X in A, and for Y in B. And then we can print out C. And I'm presuming that these things look the same. I'm hoping that they're going to look similar or the same. There's a lot more that was thrown out on there. Okay, X, Y. I wonder if a no wouldn't be like that. So I've got to be careful about doing that. So that's not going to be quite right. Therefore, I might have to go to this one. Oh, that's doing an operation on it though. It's actually doing X plus Y as well. I'm going to bypass it and leave it for now, but we get the idea that we can, or at least you can see that there's combinations here where we can combine both of them into the same thing effectively. So in fact, maybe I just wonder if I can take in the zip of AB. So I've got a double in, there we go. And then it gives us XY for XY in zip AB. I wonder if that's going to look more similar. Yes, it does. There we go. We've got exactly the same thing. Now, this one here is beginning. I'm just going to say it's beginning to look heavy, and I've actually even stuck the append down here. You know, the convention is really to put it like that. I kind of combined it into one line. But the giveaway was that, and this is quite a common like Pythonic pattern or whatever, is if you're creating a blank list and then you're doing an append, if it's relatively straightforward, I believe it's actually faster as well. Not that it makes a difference for small lists, but if you're doing something that's big, not only is it more efficient and cleaner to do it on one line of code like this, and possibly more intuitive to read. It was certainly the case it's more intuitive to read over here for our squared lists. So for basically this one here and this one, it's quite intuitive to read. It's quite nice. X squared for X in my list, because that's what we want to do. We want to square all numbers in my list. So long as it doesn't get too big, the list comprehension is quite good. But I've even found in some cases that the list comprehension, because you can split it over multiple lines. So if you did have something a little bit more complicated, you'll literally just split it over multiple lines like this. Right, and then it's quite clean again in terms of sort of what you want to do. Now you could argue that you've lost all of the advantage of saving like your lines of code, but anyway, that kind of like covers combining multiple lists into one, flattening a multi-dimensional list. Again, we can see that here we've got this like we got a list containing lists. So effectively, what looks like an array, a list of lists is an array. It's a 2x2 array effectively, and we can flatten that out, and it does it in one line of code. We can put it all into a for loop. So if I was to take this one here and let's just comment everything out above it. Don't want to double comment things. I might end up double commenting some stuff. / over there. Just over here, we could then do print flattened, and originally if we were to print this looks like, this is actually what it looks like, which is, let's just do it properly. Right, it looks like this square matrix. That's actually sort of like its physical shape as it was, but we're flattening it out, so we're just going to turn it into one big line. So it will look like this. So we've taken all of the components out. Now we can see that there's no list nesting in there anymore. It's all just one set of items, and that's got its use cases as well when you want to like just go through traverse through all of the items. So I guess we move on. Where did I just click on there? Namespaces, what is scope, what are decorators, dict and list comprehensions, we've done that. Okay. Again, something here, what is lambda? What is lambda in Python, right? Something that I try to avoid at all costs. Although it's convenient, I just don't like the fact that you've got the word lambda in there, because it's kind of got no purposeful meaning. Lambda comes from the Greek letter of the alphabet, as far as I'm concerned. That's what it is. But this concept does exist. It exists in Node. I think the Node version of its existence is a little bit nicer, which is it's sort of like this anonymous function with this arrow pointing to the rest of the code like that, and then everything goes in the code. So that's you know, the Node version of it. And then you could put in your variables a comma b, and then you know the block, you know, in JavaScript or Node.js, you know, whatever code you have, right? Okay, so B looked like something like this, and then it would operate on A and B. Now, let's just comment all of this out because we're not going to be needing this part. Control / we'll go to the top. I'll comment this one out as well. The lambda function does exactly the same thing. It's like this anonymous function. So anon, there we go, anonymous function, right? And we could set it to this lambda function. We can see that lambda's there, and then we can take this variable x, and then we can do. I just want to make sure, I just want to have a little eyeball, make sure that I get my syntax right on this one. I don't even want to do an a and a b yet, but x and then x squared. So I wonder if I can do an, just how I can call it, of 2. Right, I'm just going to print F5 just to see if that works off the bat, or if it throws me something. But yeah, it didn't throw me an error, so that's good. So now let me just print and 2. There we go. And I'm hoping that I get 4 out of it or something like that, because yeah, we do. Right. So, and this is a thing about lambda functions. You can see I don't use them that much, but because if I do, they'd be a bit more familiar. But basically, this is the argument that goes in, and it's gonna. What is the lambda function? Why I forgot like a mini version to it? It's because I can do this, right? Def of my anonymous function, right? So all I've really saved is calling, creating something in the memory that. You know, it now has to store where function exactly exists, whereas here it's like a one-line function. Now it's in an, and then if an doesn't get used anymore, then it sort of like disappears. So, and you can kind of like stick this anonymous lambda function into other functions, and it's kind of like a one-liner. Now I could have done the same here, which is I pass in this value x, okay, and then I return x squared, right? You know, you might argue with me, or you might say that, hold on a minute, you know, if you like list comprehension, surely you should like lambda functions, because what I'm about to do now is to turn this function into something that looks very similar to a lambda function. Now, I'll just call it f, there we go, right? Or I could call it underscore, there we go. I think that's allowable, because I could run underscore of, there we go, open brackets, and then it takes in this any, right? So I've now, I don't want to use underscore, but like, you know, let's just take in, we'll call it f of x, right? This construction of the anonymous is nearly no better than this, but anyway, behaves like that. It's got that kind of behavioral pattern. Now, if we go on, that we if we go on, then we've got over here. Let's just do it. Our lambda AB. Now let's just do the exact replacement just to see what it exactly looks like, and it would look like this function here. So we could overwrite our function. We can do define our function again, and this time we're taking the arguments a and b, and then we do whatever we want, like return a times by b. There we go. So I've actually saved no code, no lines of. I've saved no. I've created myself no beneficial value as far as I can see, nearly, for the construction of at least simple lambda functions. But anyway, that's what they do. So let's just go through it. Lambda is an anonymous function in Python that can accept any number of arguments, but can only have a single expression. So, you know, it does this one thing basically. So I guess it's a weaker version of a function, because in this function here where I've got that return AB, I could have put it onto multiple lines and done a whole bunch more things, like, I don't know, A equals A squared, let's square it, and then B equals B plus 200, and then return A plus B, right? So our function was, generally speaking, more powerful. And we come across many cases where we just want to do this simplistic thing. So we want this kind of like anonymous function, basically, that just does something very simple, which is A times B. Right, and you could even say 1 and you just put in A times B. There are cases when you can't do that, because like you want to do other things, because you needed to pass a function into another function. That'd be one case for it. So where are we at? It's generally used in situations, requiring anonymous functions. It's generally used in situations requiring an anonymous function for a short period of time. That's kind of like its purpose or its use case. Lambda functions can be used in either two ways. So here we are. We've got this multiplication thing, and we could stick it straight into the print statement over here. But then again, I could have done, so I'm going to do that here. I could print mul, right, and then 5 times 6 will give us 30, right? But we could also print f of 5, 6, right? So again, and in fact, this one now even looks a tiny bit shorter. Both should give us the same answer, because they're both returning us A times B, and they do. We get 30 over here and we get 30 over here. So it didn't like wholly serve its purpose in this particular example yet. But one nice thing that we were able to do is you've assigned this lambda function to a variable, whereas over here we've kind of like defined the variable here. So I guess we could point it to something else, but whatever. So that's one thing that you can do. But the other thing is wrapping a lambda function inside another function. So I think this is going to be probably more of a use case. I'll take this one out if I can. Copy that. Paste that over here. I'll tab it properly. Right, let's get all of this working there. So we've got our function. So this is like our regular function now. And it takes in this argument, it takes in this value n. And I'm actually reading this straight off of the code that I've copied here and pasted into my stuff here. So I'm literally interpreting what it's saying anyway. But we get this value n over here. So whatever goes into my wrapper, so when we call it here, my wrapper, it's taking the value of 5, and then it's doing a of a times n there. So I'm just wondering what the lambda thing there is. A times n. It's, why is it going to get? Oh yeah, here, because we're going to do. We set my 5 equals to wrapper. This one's an interesting one. Okay. We set my 5 equals to wrapper. Wrapper calls the value 5, but how does a get in there? And then we do mul 5 wrapper 2. Okay, fine. So what happens is, again, I don't like this because it's not so intuitive. It's even hard for me to describe it. I'm really tempted to do print just to like nearly like explain it. So I'm going to cut these things out of here for the moment. There we go. So we don't have any other print statements in here, and I can't print a in there, but I can print n, and I can sort of like run it like this, because what we should get, and we do, is we've called our function myWrapper, we've called it with this 5, so that's gone in and that's taken 5, so we've printed our value of 5, but then we've returned back 5 but it's taken that return and it's multiplied it. This mul5 has multiplied that by a, so it's taken in the value of 2, and therefore we've got 2 times 5. So we've got whatever a is, we're going to get a times by n. So a is 2, and it's going to be multiplied by n from up here. So we get 2 times 5, and the output's going to be 10. So that's kind of like why I'm not a huge fan of it, because it becomes like less obvious even in this easy example, but nonetheless that's kind of like how it works. So that's kind of like the use case for lambda functions. That's where they are. They do crop up. I try to avoid them like the plague. Whenever they do, I do try to replace them as best I can, also with these single functions, but sometimes you can't avoid it. I think this places in tkinter, which is one of the Python modules that you can't avoid it. So you have to go along and use the lambda functions. It's not too bad when you do use it, it's fine. But I know that I'm not alone on that. Like I've seen it in the forums and things where some people are like a little bit averse to using it, that's all. So let's move on. How do you, okay, right, copying of objects, right? This one's quite important. The concept of the like shallow copy and deep copy, although the deep copy is more a case of how you create a copy or what you do with things. So, and okay, there's this copy thing as well. So in Python, the assignment statement operator does not copy object. It says instead it creates a binding between the existing object and the target variable name. So it sort of like points it to something. Remember that the equal statement doesn't mean something is equal to in coding. It's kind of like an assignment. It's assigned the value of. And the equals, like there are logical equals that we know of equals in our mathematical stuff, is like double equals in most languages, and so it is in Python as well. So this assignment statement in coding, what it does is, if we've set, so let's get rid of this now, because we are, in fact, I might make a little section header. There we go. I'll be very sophisticated there. And we'll talk about copying an object in Python. So something like this. How do you copy an object in Python? Right. And the thing about that is, if I say x equals, and then sort of like 1, 2, 3, 4, 5, something like that, and then I can say y equals x. It's kind of like, have I created y equals x? Like, what have I done? Have I created a copy of it? Or what does it all look like? So I could do print x, and I could do print. How about typing print right? Print y, and run it. And there we go. It looks like we've printed the same thing, because we've got x over here 1, 2, 3, 4, 5. We've got y over here 1, 2, 3, 4, 5. So it all looks fantastic at the moment. But then if we do something like I don't know, y, the first element of y0 is equal to 100. Let's see what happens. And look, lo and behold, right, we've got this, which x is also 100. And I'll literally like separate it just so that you can see that I'm not cheating or whatever. It really is that x, right? That's what x is. And let's just steal all of this because I can't be bothered to copy that and paste it over here. Y, just to segregate them. There we go. I only changed the value of y0, the first element of y, but it's magically changed x, and people have like this conceptual, like, oh god, this is like, you know, sort of like, this was unexpected, an unexpected behavior of Python. Python's terrible, Python doesn't work, right? And the thing about this is what you've actually done is, and this is something about mutable and immutable objects. I don't know if we'll get a question on that somewhere, mutability, let's have a look. I don't see it, but we did come across it in the previous session, which is basically that lists all of these collection types of things, all of these sequences are mutable. So lists are mutable in Python, which means that like we're pointing to the same piece of memory space. We're like pointing to the first address of the list effectively, is like what we're doing, and then the list. So it looks like it's always in the same place. I wonder, in fact, if I do one of the other things, which is the ID, I'll print them underneath it. Print ID of X, and also print the ID of Y, which is kind of like their memory addresses. I'm quite sure that they're pointing to the same thing, but I just want to verify that. Yes, they are. So remember, this ID value, it literally tells us, returns the identity. It's unique among simultaneously existing objects. Well, these things are not unique, though. They're pointing to the same thing. They're like, it's literally the same bit of memory space. Now, how do we break this up, right? If we don't want to have that behavior, sometimes we want this behavior, so it's nice to have it, right? Sometimes we don't. Well, the way of doing it is x.copy. Now we create a copy of the list like this, and then if we run everything, when we do it, we no longer get our undesirable effect, as in we no longer have changed X. We've just changed the first value of Y, which is maybe what we wanted to do. And more importantly, or not more importantly, but one thing that we see out of this is that they're pointing to two different memory addresses. So they're now in different pieces of memory, and we've created a copy of X effectively. That's what we've done. I'm doing this live, so I hope I've described that as well as I could have described. If you've got a better description for that, by all means let me know. I think I described that one quite well. I describe other things badly. I think I nailed that one quite well. So that's effectively what a copy is. Now, there's different versions of a copy, right? Let's just read a little bit extra here. The assignment operation. So the equals does not copy objects, right? It just assigns something to something else. That's what we saw. Instead, it creates a binding between the objects and the variable name. To create copies of iPhone, we need to use well, we don't need to use a copy module necessarily. You saw that I was able to just use .copy, so I could copy the list. But you can also use the copy module. Moreover, there are two ways of creating copies. For the given object using the copy module. Now, what does this refer to? We've got this shallow copy, right? And then we've got this deep copy over here. The shallow copy is a bit wise of an operation, right? And the best description really of is this deep copy, which is copies all values recursively from the source to the target. It literally, I think it kind of like traverses through the whole lot and copies all of the items piece by piece. So if you've got like lists inside of lists, I think the deep copy will capture that, whereas the shallow copy won't capture that. That's kind of like the key difference. But really, in terms of getting it separate in the memory, so you don't make this fundamental mistake, this much more important thing, this was sufficient. So this .copy was sufficient to create a copy of the item in a different part of the memory, so you can operate on them separately. But let's see the shallow copy anyway. The copied object is created as an exact copy of the values in the original object. If either of the values is a reference to other objects, just the reference addresses for the same are copied. And I think that's kind of like the slight different bits, which is that if this actually was a list in itself in here, so it was a list that contained another list, so sort of like hello world, I believe that if we would then need the deep copy, and the shallow copy wouldn't be sufficient if we wanted to change this item in the list, because this is now mutable. So you've got a mutable object in a mutable object, and for that you would need a deep copy. So that's kind of like what copy is, and also what deep copy is. So I can't like leave it there, because I've never used deep copy in Anger, I don't think, but I know like what it's for. But I certainly have used copy many times in many languages, or the equivalent of that, because many times, like, you know, accidentally you've overwritten something that you wanted to store. Like, say for example, I don't know, you're taking an image and you want to do like an image processor, and you sort of like want to find all the edges or smooth it or something like that. So you've got your original image, and then you've got your other image that you want to blend, and then you might want to do another operation. But if you've operated on the original image in the first place, then you can't do your second operation or your third operation. So no, all of those drawing packages and things where like you can sort of like make your picture blue or then make it red or something. They're operating each time on the original version, and then they're creating like these new copies, and then you pick the one that you want and you save it. So that's copy. How do you copy an object in Python? That's how you copy, and also in theory how you deep copy an object in Python. So we move on to number 26. What we're going to get to, we're going to go all the way to 38. So another 12 to go, is it? So what's the difference between xrange and range in Python? That's an old one, that is, because xrange, I don't think xrange gets used anymore. So I don't even know this, although I saw a video on it from, it wasn't Guido van Rosen, but it was one of the like co-creators or creators of Python, and he was like raving about xrange and everyone was clapping him. But I've not used it, I don't think, nearly ever. But xrange and range are quite similar in terms of functionality. Fantastic. Well, that's one reason to not use it then. They both generate a sequence of integers with the only difference, so here we are, the only difference that range returns a Python list, whereas xrange returns a Python object. That's interesting because I thought a list was an object. So it still doesn't tell me what the difference is. So how does that make a difference? Oh, there we go. That's a good question, because that's a question we were just asking, or at least I was just asking. It sure does, because unlike, here we go, I see the word yielding in here. It sure does, because unlike range, xrange doesn't generate a static list. It creates the value on the go. So that's going to have quite big advantages for memory space, basically, because when you create a list, you are occupying all of the, so x, well, I guess we had a list up there already, but x equals 1, 2, 3, 4, 5, which is fine when you've got something small, but we've now occupied 5 pieces in space, whereas imagine that we had x equals 1, and then we went and did, and this is what these iterating types of things do with this next function. We get then x equals 2, and then x equals 3. Each one of these only contains like one integer size, whereas this thing here, we've had to allocate 5 integers into the memory of however much memory space that would take. I can't remember the, there is a Python function for determining the size of the memory that something occupies. I might attempt to do this, but I don't know if I'll get it. I'm going to try and do it in my new favourite best friend, which is Claude. I've migrated from, I used to use ChatGPT, then I used Google Bard, now I'm using Claude. And what did I want to do, which is, how can I determine how much a list has taken in Python. There is like a one-liner or a small function or something that does it, so just kind of like want to see it. But it'd be nice if I can just pull it out quickly, because it will show the case and example. Yeah, Python, sure. Okay, import. Oh yeah, there we go. Sys get size of. Fantastic. So let's just do it, which is import sys, and then oops, just sys, and then over there. It's even got the x in there. Print get size of x, right? So what I'll do is copy that one and sort of like paste it in here, because that's what our first x is, and then like, you know, any one of these other x's, maybe I'll each version, here we go, we'll print it all over the place. Right, let's F5 to run it. Yeah, so here we see, I'm going to get rid of all of this other stuff before, just because again, just because it convolutes everything that we've done. This kind of like highlights it really, really well. So great, great use of our large language models. Here it's size 104, and these ones here are size 28. So this xrange, I've never used it, and I probably should at some point. It creates like this thing that's, I guess it's like a generator. Which it just gives you the sequence, and so it only ever gives you one item at a time, whereas the range plonks the whole thing into memory. Now, we're generally speaking quite lazy. We've got lots of memory. Quite often we're operating on small size lists like this anyway, so it doesn't really make a big deal. But if we were operating on something that was very large, maybe even it was like lists of very long strings, so it's occupying even more memory, we'd kind of like run out of memory or something like that. So we might use the xrange instead to do it. And if we didn't use the xrange to do it, we might use sort of like some sort of list, some sort of range in a function, and then use the yield keyword. And the yield keyword kind of like gives you this this generator effectively. So I should write the word somewhere in there. So basically what you have is range. Range goes to just occupies. It's pretty standard, whereas x range is some kind of generator. There we go, when I can type. So that's basically that, I believe. If anyone's got any questions on it, or if you've got any comments, if you think that I haven't said that right, throw your oar in. But we can like observe that this list has just cost us more space than pulling out like 3 single items if we're able to do it. So we were able to at least demonstrate that straight off the bat. And I knew to do that just because I saw the yielding keyword anyway, which is exactly where it's going to go. And actually I see this generator keyword in big fat bold as well. This technique is commonly used with an object type generator that has been termed as yielding. So it's been given its own word. Yielding is crucial in applications where memory is a constraint, right? That's literally its case. So xrange is important. So I should be using xrange for some things, I guess. I need to think about where. Quite often we don't need to, so we just do range. Creating a static list as in range can lead to a memory error in such conditions, while xrange can handle it optimally by using just enough memory for the generator, significantly less in comparison. And basically, I think the thing about this is if I do x equals, I wonder, because no, right, x for x in range, right, I'm cheating a bit, but 100, right? If I run this again, now I've got 100 items, right? It's now gone to 920. So you can see where we're going with this, right? Because if I stick in 1,000, right, it's now starting to occupy like lots of memory. Now I want to like go to a meaningful list. I'll use an underscore and another underscore. There we go. I'll go to 1,000,000 now. I haven't even done anything, right? It's now had to allocate this block of memory. It also cost a bit of time. I don't know if you noticed it, but it cost a bit of time in terms of kind of like creating this little piece of memory. So whereas these tiny little things here are much smaller. Now if you had 65 million because you had one for every person in England because you wanted to take people's votes and they were all booleans, so it's something like, even if it was like true, so you're a bit more efficient, true for x in range, I think that would be a whole bunch of trues, basically like ones. Right, you can see it's like thinking now, it's stopped. I have hit the run button and it's kind of like stopped. 65 million was for a lot of stuff. There we go, it's finally done it. It's quite a large thing, and there's a whole bunch of trues somewhere in this in our memory space. And I could actually print this out, but it prints 65 million trues. You go true, 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 true. So I'm not going to print that out. But the point is that that's the difference between range and xrange, and that highlights, more importantly, if you're ever asked a question, I guess, is wherever you can use something that is yielding, or a generator. So generator, I'm going to also put the word in. Well, okay, generator. Yeah, these are the terms, basically, generator and yielding. That you want to do that. Let me just shrink this down to a smaller size, so 1,000. There we go, or 100, because our point was more than made by doing it with 100. So I think that was pretty much that for it. Yeah. Okay, well here we go. That's why I haven't used xrange. No, xrange has been depreciated as of Python 3, right? And the reason why is because I can go along and be an idiot quite happily, ignorant in bliss. Now range does exactly what xrange used to do in Python 2. So that video that I watched from one of the original creators who was probably a legend in his time, is no longer applicable because now kind of like we always want to do that. So and I was actually thinking when I was constructing it, range does create, it is actually creating a generator object, and you can kind of like see that by, I think, hover overing it. The range object start, stop, and step. The return an object that produces a sequence of integers, start to stop, by step, then a start, stop, step. It doesn't have the rest of it actually, but I believe that, or at least if I did x equals range, right, 100 or 1000, like some big number, x equals range, and then I did the same thing, this get size of x, just on x here, right? So it's no longer created, it's no longer this list comprehension that's making this massive thing, but it's just this whole big thing. If we run it, we see our first one still 920, but look at our second one. It's a small item. So it isn't this big whole long range. It's literally one part of it. It's like the first element, the size of the first element of it. And then when you iterated for it, it would be the size of the next element and so forth. So it's a very efficient object in Python 3. I started in Python 3. I have seen Python 2 code, but I've barely ever touched it. It's legacy as far as I'm concerned. I'm not old enough for Python 2, but other coders will be. Right. What is pickling and unpickling? I've seen pickled files and unpickled files. I'm not the expert to tell anyone what pickling and unpickling is to a reasonable degree, but I have seen it come about. And but in very simple terms, I'm wondering the best way of showing this, which is generally speaking, let's comment all of this out now because we've moved on. So bye-bye to all of that, and then we go over to here, what is this, pickling and unpickling, copy that. That's our next section. Is when we want to store data in some way, shape and form, our usual ways of doing it is to read a text file, or to read a CSV file more commonly, and it's something like you'll have a file which x or file equals, and then you'll have some kind of file in your memory. Let me see if I've got a file banging around, because I've always got I got like a hello text, right? There we go. So it's something like this, right? So I can do I'll copy the full path just to make sure that I don't get it wrong. Let's just have a look. Can I copy the full path? Copy path, there we go. So file equals, let's get rid of all of the sidebar explorers so we've got some room. Not that one there. And let's just make sure, turn these all into forward slashes, right? So we've got this file like this. We stored our data, right? It's more pertinent, it's more like useful. CSVs are a bit more useful, but I'll start with the most inefficient one. So I think you can use the with statement there, with open. I've got it already there, right? But this piece here is now file, right? So we're passing in our file object, right? And then as f, and then we do data equals f.read, and then I think we can do print data, right? There we go. We've managed to read some data from somewhere. We've got that, and we could also write data as well to our files. We can write and read data, right? And this isn't the most efficient form of data. It's a standard text file. We can then go to a CSV file, and I actually recommend, if you're ever doing a CSV file, that you don't even do the with open statement like this, but instead you import pandas as PD. It's an external module, and you'll do something like pd.read CSV. I'll even have an attempt of doing this. I don't know if it'll work on a text file. Let's just move it down. whoops, I'm just going to shovel it down at the bottom there. I'm going to try to read the CSV of the file because it's not comma separated, so I don't know what it's going to do. It's probably going to throw an error actually. And I'm going to put it into a pandas data frame, and then I'll do print data frame. That's either going to throw an error or not. If it Control Z, right, F5 to run it. Yeah, it's thinking. I think it's going to throw an error because it's thinking for too long. Oh no, it did something. Did it print a data frame though? I don't know if it did or didn't. Let's just commonly say, well, it didn't fail, it didn't crash. So that's a good statement. Like, let's just try and print the data frame then, see if it prints something. I don't know, it doesn't look... Oh yeah, it does, because they've got 0, 1, 2, 3, 4, 5. Yeah, it's passed this into a data frame. It hasn't done the best job in the world because all it sees is this thing as the header of the rows, and then these are the rows, 1, 2, 3, 4, 5 rows. But anyway, we can read a text file quite easily. We can read a CSV file. CSV file is more efficient than a text file. And generally speaking, I only really ever use CSV files. Sometimes, I don't know, I might use a text file. I'd use a JSON file sometimes. So there's all these different formats. Well, a couple of these formats are these pickle files, basically. So the Python library offers a feature, serialization, out of the box. Serializing an object refers to transforming it into a format that can be stored. Okay, well, we can store a CSV file and we can store a text file, so we can do all of that anyway. But so as to be able to deserialize it later on and obtain the original object. Here, the pickle object, the pickle module comes into play. Pickling is the name of the serialization process in Python. Any object in Python can be serialized into byte stream and dumped as a file in the memory. The process of pickling is compact, but pickle objects can be compressed further. So here's the kind of like advantage, I guess, is this compression. Moreover, pickle keeps track of the objects. It has serialization, and the serialization is portable across versions. So it gives you, like, I don't know, it's like an extra denser version of reading and writing a CSV file, and it looks like it's in memory as well by the sounds of it. So, and unpickling is a reverse process. So so here we go. We've got our data here. Here's our Python objects, and this is the pickling process. It goes one way, which is it goes from I think we can see the arrow already, but it goes this way. If I was to draw the arrow, that's pickling, and I'll draw unpickling in a different color. Unpickling is going that way to get the Python objects back. So you're putting it into like this. What did it say that we're putting it into here? I just want to make sure that I get the right term on it. Any object file giving in the byte file. I think it's in bytes, basically. Oh yeah, here it goes. It's the byte stream. Yes, so it puts in a whole bunch of bytes. So that's basically what it does, and it pulls it back out. So that's kind of like an understanding of it. I've seen it used, like data scientists like use it for sort of like big file types, but I've never really had the need to use it. So I've always been able to, but maybe that's because my file sizes still weren't big enough to need pickling, and I was always being able to use the pandas read and write CSV to do most of what I wanted to do. And you can get like millions and millions of rows of pandas read and write CSV without too much overhead. So it's really, I guess, pickling might come in when you go above that, or maybe there's a bit of a speed advantage possibly. But anyway, that's pickling and unpickling. So just as a global understanding of it. So the next piece is what are generators in Python? So that's the next bit over here. And what I'll actually do is I'm just going to do a retweet quickly of the tweet that I did, just so that if anyone does want to join, retweet. and I'm on live now, dot, dot, dot. There we go. I just retweeted the same again. So what are generators in Python? Well, we kind of like already mentioned it sort of like above here in this xrange thing, but we were told that xrange had been depreciated because we already had this yielding thing, and we've seen this generator keyword already, so we already have intrinsically, even if we didn't know that we were using it, we are using a generator whenever we use the range function in Python, which is nearly all the time as far as I'm concerned. I use it tons because it's like just an extremely convenient object to use. So what are generators in Python? Generators are functions that return an iterable collection of items. And here's the important bit, if I could highlight it, one at a time in a set manner. So one at a time in a set manner. The second important bit, like two important bits, one at a time and in a set manner. Generators in general are used to create iterators with a different approach. They employ the use of the yield keyword rather than return. So that's the key difference between a generator function that's a generator and a function that returns something. So we'll see one because there's one in here. And as usual, the one that gets used is the Fibonacci series. So there we go. Let's just do this and we'll copy it out and we'll see it in the actual code because we can like run it ourselves. It's always better when you run it yourself and have a look. And if you've got any comments or want to say anything about that, by all means do, or tell me to run it in a different way, or tell me to try something else. Feel free to kind of like put it in the chat. I've got my eye on the chat on the side. So let's just get on with that then. So our next little section, which is what are generators in Python. So let's copy this piece of code here. I'm so lazy. Like, okay, one thing I'll mention is I wonder if it's got 1, 2, 3. It's got 3 indents. That's terrible. Terrible Pythonic coding. There we go. Let's get our indentation correct, right? The default indentation in Python is 4. That's kind of like, that's the zen of Python. And that will be, and in the previous session we talked about PEP 8 or whatever. Like there's a standard like indentation that's used. One thing, by the way, that Python doesn't let you do is do something like this and do uneven indentation. It will throw a little fit. The white space is important in Python. So anyway, let's just see this, or let's just create a regular function. So def sum function, right, that looks like this, and then it return something. So I don't know. Let's just think of something that we can do. So we'll take an argument or something that goes in there. We'll call it A, right? We could call it N, just like the Fibonacci function. So, and I'm making this example just straight up off the bat. So let's just call it, we create some function, and we're going to call our function later. So x equals some function, okay? And we're not going to call our Fibonacci one yet. So, although I don't think it does anything anyway, because I'll have to print it out, so that's cool. So we've got some function, and then we're going to do something like for I, and you can see what for I in range, there we go, and then N, and then maybe, I don't know, let's create a second array here. We'll just call it squared. We'll square it. We'll do what we did above. So squared numbers is equal to like this blank thing. Remember, I could use a list comprehension. I should be using list comprehension. I'm not. I'm going the conventional way. But I can do something like sq.append and then I squared, right? There we go. And we'll square all the numbers and add on 100, okay? Right, and then I will return back square, right, like that. So x equals some function, and then let's do print of x, right? And in our sum function, we've got to pass something in, and basically it's going to be how long our list is. Let's not make our list too long, so let's make our list 10 items long, right? And all it's going to do is square the number, and it's going to start from 0, so it's going to square 0 and then add on 100. So the first one will be 100, then it's going to do 1. 1 squared is 1 plus 100, 101. Then it'd be 104, 109, something like that. That's what we're expecting to get. So we run our little piece of code, and Yep, indeed we do get that. 100, 101, 104, 109, 160 and so forth. Right, fantastic. But it's given us all of our answers back all in one go. And the point of the yield function is something like, I guess it makes more sense to put it into a while loop for a start. I wonder if we could just do yield like that square and just see what happens to it. So let's just run that. I wonder if that will work off the bat. Okay, it was giving us back a generator of some function. So not quite what we wanted. So let me just hit return on that one. And I'll go with the conventional one because it's right there anyway. But basically, or can I do x.next? I wonder. Let me have a little bash at that. I'll try the yield thing one more time. Because x.next, okay. I wonder if we get that or if we still get memory bits back. Because if we do, then I'm just going to go to the original thing. Okay, yeah, what's actually happening there? I can't, my example won't 100% work like this because I'm actually returning the whole array back. What I actually want to do is inside the for loop, I presume, well, maybe that would work. No, that wouldn't work. What I'd actually want to do is yield back inside the for loop, probably the I squared. So I'll move on to the other function. So we'll keep this one like how it is when we'll just do the return, right? And we'll call this the classical function. This is what we're used to. This is what we do all the time, right? We're returning back our squared functions. So that's all. So I'll get rid of that for now, right? And the Fibonacci is quite a nice one to do it on, but I could do it on this one as well. But we're just going to call it our classical function. So here is our standard. That's our standard classical function, right? Now we're going to use this yielding function, right? That yields, there we go, right? And what's actually happening here, right? We've got this function, right? It's going to create the Fibonacci series, what we're going to do. But basically, it's got P and Q. It starts off at 0 and 1. They're the first two items of the Fibonacci series. And then it says while P is less than our number n, so we're going to calculate up to a certain number of Fibonacci. So in our case, in the case of the example, it's going up to Fib 10, right? So while P is less than 10, well, P at the moment is 0. While P is less than 10, yield P. So the first answer it's going to give back is P. Right, fantastic. Then it's going to continue afterwards, but it's going to wait because it's yielded it, and that's what the yield keyword does. I wonder if I hover over it. No, it doesn't do it like that, but we'll have a read of the description. It's going to give back P, and then it's going to wait for us, and then we're going to continue afterwards, and it's going to say P comma Q equals, and then Q, so P is going to get the next value, which is 1, and then Q is going to become P plus Q, which is 0 plus 1. So we're going to get 0, 1, 1, then we're going to get 2, and then we're going to get 1 plus 2, which is 3, and then get 2 plus 3, which is 5, and that's going to be the construct of the Fibonacci sequence. So I wonder now if we can do, we'll just do a print of x. I just wonder what we see there, if we also get that memory address thing. Yeah, we do. We get this generator object fib at that, and that doesn't look very helpful at the moment. Don't like that, the look of that, right? But that's fine. We'll be able to deal with it because we'll have a little read here, right? Generators are functions that return an iterable collection of items one at a time. We've already said that in this set manner. Generators in general are used for collection of iterators with a different. Are used to create iterators with a different approach. They use the yield keyword rather than the return keyword. So we have used the yield keyword here rather than returning back P to return a generator object. So right, what is this generator object? Well, you know, it's this thing here, generator object fib at this P. piece of memory, right? Well, that wasn't very helpful and descriptive of us. Let's try and build a generator of Fibonacci numbers. Now, the next bit is here is iterating using the next for Python 2. So this seems like, I wonder if this is an old article, but anyway, for Python 2, use next. I wonder if we could just use next as it is, but let's have a look anyway. Print x dot next. No, you have to do the double underscore there. Okay, x dot next, right? So there's a built-in function there. Let's just hit F5 and run that one. I wonder what. Yeah, there we go. We get a 0 at least, right? So our first object is, or it's not very helpful, like this just printing x. That doesn't do anything because it's like the piece of memory. But what we're going to do is like nearly like a linked list. It's going to traverse through the iterations of it. So it's only given us the first item, but we can keep on doing this, right? We could even do it in a for loop if we wanted or some other way. But let's just print the first few of them like that. And I think that when we run this, we're going to get, you see, like we've got the 0, 1, 1, 2, and so forth. Let's just do for I in range. Again, you can see like how often I use this stuff for I in range, and I guess we want to do 10. I wonder, because at some point we'll run out. I can't remember what happens when we run out. I think it throws an error message. Oh, I don't want to print next loads of times. Now that will definitely run out. Exception, no description, stop iteration. Right, we've overlooped it. But let's just do that loads of times, and we do the iteration. And what's actually happening? No description. We still run out. Probably looped too many times because we hit the value of 10. Because when we got to 8, it throws an error message. And I could error handle, by the way. But I'm not going to bother. I'm just going to go for I in range. Well, if fib is 10, let's go to 9, right? I don't know, go to 5. There we go. I'm hoping that's sufficiently low. There we go. So we just done it iterate. We've got 1, 2, 3, 4, 5 objects. We could have done a little bit more. I think 7. There we go. Right, and each one of the, again, if we were to steal from somewhere and get the size of, right, and kind of like, where was it? Get the size of x. I wonder if we can get the size of x dot double underscore next in there. 5 just to run it. No, it doesn't work like that, so maybe I just have to do get the size of x. But basically what we're going to do is if we get the size of x, or maybe, am I getting the 5 range? I mean, yeah, get the F5, let's just run that. But basically it's going to be a bunch of small items, right? Each time is this, I guess it's 216, there we go, 216, 216. But I presume that's possibly the memory location, so I've got to be a little bit careful about that. But anyway, I might take this out because that's possibly not 100% correct on that bit. But one thing for sure is that this yield keyword basically only does the it creates an object like our range object, but it's our own personal customized object in a function, whatever function we chose to do. We chose to do the Fibonacci function, but it just says, hey, just calculate the next value. Don't put them all into one big humongous list and return me back this massive list. You know, just give me one value at a time. Now, where's that going to be useful? Well, it'll certainly be useful for Fibonacci, because if I wanted to calculate Fibonacci of like the millionth number, I'm going to have this humongous like thing, whereas and it's going to like stack overflow me. It's going to run me out of memory. But if I do a yield on it, and just doing for I in range and then keep on iterating to work out the next value, all it ever needed to do was to get the first 2 values to compute the next value. So it didn't need anything much more than that, and it can just keep printing that have that tiny piece of memory and traverse through it singly. So that's what yield does in or that's what generators are in Python. So they're extremely useful. They're memory efficient. They go through a collection of objects one at a time in a set manner. Saves you memory. There we go. So what is Python path? Okay, I'm hoping that this one's a quick one, but it's Python path is an environment variable where you can set additional directories. Basically, every time you see me, when I hit F5 in VS Code here, and it runs its stuff down the bottom, you see all of this bunch of stuff here. Well, it's actually a path to where my Python executable is, and it sort of like looks actually sequentially in order. And if it doesn't find it in the first folder, it looks somewhere else, and so forth. That's what Python path is. I wonder if it's got anything extra to add on that. Python is an environment variable that which you can set to add additional directories where Python will look. Oh yeah, okay, fine. For packages. So basically, usually we do something like this, which is, I'll stick that one in here, copy that, and let's stick it on the top. I've got things all over the place now, so I've got to be careful about that. Let's get rid of that one, and we'll comment all of these out because we don't need them now, and we go down here. And we go to this Python path thing. So what is this Python path exactly? Right. If I want to import a module, right, like where's it imported it from? Well, like where does Python know where to look for to get it? And actually, I can right click on it and go to definition, and it will actually open it all up. There's a file that exists somewhere. Here's the breadcrumbs for it, and this is the whole thing: user admin app local Python 3.11 lid site packages numpy. Finally, it gets to it, and then there's the init.py, and this is at least the beginning code of numpy. I won't go into all the bits. I don't know why, for example, some of these things have got squiggly underscores. That'd be a bit concerning. But maybe none of my business to an extent, but that's kind of like at least where NumPy kind of like partly lives. So it's gone somewhere and looked for it. And generally speaking, if I've got a module somewhere, one of my modules in here, I can sort of like import. And I wonder, I've got to be careful about what I import because I've got like test import things. I wonder if there's something that I can import. But basically, I could import any of these modules that are here. Let's just do import. I don't even know what's in here. Test underscore type, just because I see it there. As TT. There we go. I'm aliasing it to be shorter. Right. TT dot. Right. And there we go. Anyway. I've done G in greeting or something. So I've created it looks like I've created a class, I've created a function, and I've got two variables. I've got G and X in there. I don't even know what it's for, but it's like I could print it out. I literally don't know what to do. But the point is that I can import a module, like an external module, and I can import a module that I've created from somewhere. But also, if this module, normally you want to import modules that exist within your folder structure. We saw that I opened this up, my code lived here, and this other code lived in the same folder as this folder was, which is fine. And if it lived in this folder or it lived in a nested folder, there's very simple ways of getting them. And if it was in a nested folder, I think I'll just do, I believe it is import. If I do the dot, I wonder, straight away, I believe it I wonder if that's got the nested, but basically you can get nested folders quite quickly. But if it's not in a nested folder, it's in a folder somewhere else, we then have to go and tell our Python to add that folder into the Python path. Now, again, it's a frowned upon thing because what it actually means if you're doing that is you've written some code somewhere in a completely unrelated package and you're just randomly importing it sort of from your package because, for whatever reasons you had. Now, I've seen it being done where people have kind of built their own libraries and then they sort of don't want to rebuild the library and they just do the Python path thing. So they add the path. So you can do that. I could definitely like pull it up. I'm quite sure I could get it relatively quickly in, you know, Claude or Bard or any of those things, or ChatGPT. But that's what the Python path, that's what that's referring to. So it's effectively, you know, as it said, it's especially useful in maintaining Python libraries that you do not wish to install in the global default location. Well, but I nearly always install them in the global default location. So I won't come across it often, and many people won't, but it's good to be aware of it. So let's move on then. We've got the next one, question number 30. We've got 8 more to go. So what is the use of help in the dir functions? Okay, I never use help. I know what help is for, right? The help function here in Python used to display the documentation modules, classes and functions and keywords. So let's just get something that we don't know of. So I don't know. I wonder if I can do help on TT. Help TT. I wonder if I have to print the help on TT. R equals help on TT and print R. Print R. There we go. So I don't think I've got any help stuff in there actually, so it won't give me much. Oh, there we go. Well, it has actually written stuff. It was whatever was in the module. Hello 10, greeting 20. I don't know. Like, so it's some stuff. It tells you a little bit about it. I wonder if I can do help on something a bit more useful, like well, let's do another one. Help on np dot. You know, I don't know what the absolute function is there, right? Let's just see and then do print R. So this is what the help is. Control Z because I've got the the snippets on. We'll just run that. Oh, sorry, I have to hit. I'll hit stop there. Do I have to hit clear on this? Oh, there we go. Okay, I'm going to clear all of this anyway because clear. So let's try that one again. This time we won't print this because it wasn't the most useful of things to have. And run it again. I don't know what's going to come about from this np.absolute, but I'm hoping it's going to describe it in some way. Here we go. You know, what do I printed the help on the? Or maybe that was from the previous one. And it's got more as well. Calculate the absolute value element wise. Okay, it's got like absolute, what it is, and literally, actually, what it is if I hover over it, it's nearly all of this stuff that we see. So that's why I don't use help, because I use VS Code nearly all the time. I guess if you use another editor that didn't have like IntelliSense and autocomplete and the pop-ups that help you, that you might use, like some of these like Linux or Unix based things, you know, those editors that like where the real professionals use, and you know they don't like, you know, all of the help from things that come out here. I quite enjoy all of this stuff. They would type help and they would get this, which is like effectively it's probably the doc string actually. I imagine is what it might be. So, and it's got more. I wonder if I press space, yeah, I get more. There we go. And it keeps telling me until it comes to the end, right? So that's what the help thing does. Now, I did have a function above. So here, let's do help on our fib function. Let's uncomment the fib function. And let's now do help on, instead of np.absolute, we'll do r equals help on fib. Right. I presume that in order to do that, well, we haven't got any like stuff really. Let's just put in a little bit of commentary here. So we've got the args, right? The args and n, which is the max number to get to return. Well, it doesn't even return, it actually yields, right? Numbers from the fib sequence, right? Just to put in some ballast. sequence, okay, sequence, yep. And here n is an integer. I don't even know if it's going to mention, you know, because we've got some type hinting as well. So we're just going to do a help on that. Let's see what the help does, see if it works like that. Maybe I have to do help fib with the thing. There we go. So it has done stuff. Help on the fib Help on function fib in module main. This is the module main. If name double equals double underscore main, it's the module we're talking about. Fib, and it tells us exactly what we could have got had we have hovered over it. Which, so if I hover over it, it's all it tells me that it's a function. Its name is fib. It takes in the variable n. It's got an integer, and it gives us back a generator. It knows that because it's got the yield keywords, and it's giving us back a generator of integers. And so forth, and all of the arguments. So here it's the same thing. And if I press space, it gives us the rest of it. So the help function gives us our doc string, basically. That's what help does. And the dir function tries to return and that's quite a good one there, tries to return a valid list of attributes and methods on an object. It behaves differently with different objects, okay, but it aims to produce the most relevant data. And a good example of this is, because I was actually using it yesterday, so I'm good at that one. I've never used help before, and I probably never will because of the editor that I use, not because of anything else. So let's just comment a lot of this stuff out. And yeah, we'll comment all of this out. We don't need this anymore. But if we did something like, this is probably like the third or fourth time I've done a class here, but class, we've got a standard class. Let's put in another bit there, A, B, self dot B equals B. There we go. And then something like C equals my class. So something like that, and then we'd need a 10 and say a 20 for A and B. We don't even know what they are, but basically if we did print dir of C, like, you know, what's that going to give us back? So when we run that, we get back everything, all of the methods or attributes. Now a lot of these methods are double underscore methods. It's like the built-in methods. They're called magic methods or anything but magic. It's just built-in methods. And then at the end, we also see two of the attributes that we know that we put in, which is A and B. So this dir gives us that. Now, I was going through this yesterday. Here's something that's quite useful: is if we want to only see the methods that we want to see only the non-double underscore methods in there, we could do something like for I in dir C, and then if I can't remember exactly what I did on this one, but if because if the first character of it, so basically maybe if I0 equals double equals underscore, we don't want to see those, so we've got to make sure that I get an underscore, not a dash, is not equal to the underscore, is the way around we want to do it because it's more efficient. Print I, right? So something like that. I hope it works. Don't know, no idea. There we go. We've got A and B. So we've it's given us back the public. I'm going to call these the public variables, so not the private methods. So we've got the public variables back from our my class object. We've got the public variables back from my class object, and it's emitted like the double underscore in it and all of the other built-in methods that were to come with it from the class. So that's kind of like that's the dir function and the help function. They're descriptive things in general. That's what they are. Right, so for modules and libraries, it returns a list of all the attributes. So we could do dir on a module, like, you know, a NumPy for classes. So we've just done one of those. It returns a list of all the valid attributes and base attributes, right? Literally gives us everything back. And, you know, and I had to actually filter out the underscore ones just to get the ones that, you know, our ones, should we say, like our public ones. With no argument passed, it returns a list of the attributes in the current scope. Okay, let's just try that one then. So we can do print dir, which is in the current scope. So we'll probably get double underscore name in there or something, I guess. We've got double underscore built-ins, cached, doc, file, loader, name, package. Yeah, so there we go. And we've got C and I because they're in the main, they're in the global scope. So C is in there, and I must have I. So, well, did I do? Well, I've got I here because for I in DIRC. So that's what the dir function does. So both very well help. You'll probably need it much less often in a or never basically in a good text editor, but the dir function you might use that a bit more. Right, okay, what's the difference between a py file and a pyc file? A pyc file is going to be some sort of bytecode compiled file, I think. But so a py file is all of the files that we have. So like if I go to my sidebar here, you can see all of my files, I don't know, test short, test sleep, test sound loss, testing sound, test space, that's testing the spacey module, test speed, test stack overflow. This is an IPYNB file. That's a Jupyter Notebook file. This is a Markdown file. So the PY files are just standard Python files. That's all they are. I don't see any PYC files, although if I went into something, if I was bothered to, like further up, something with a bit of directory structure, I might hit some PYC files somewhere. But we can read what they are anyway. PYC files contains the bytecode of your program. We get the bytecode after compilation of a Python file, the source code. But the reality is, this Python is interpreted and is done in the runtime, and so literally it reads line by line. So we're just reading our Python files for the most part. PYC files are not created for all the files that you run. It's only created for files that you import. Okay, well there you go. That's where the PYC files are for. Before executing any Python program, Python interpreter checks for the compiled files, so all of the imports. That's why it's useful to put the imports at the top anyway. If the file is present, the virtual machine executes it. If not, it checks for the Python file. So I guess that's basically it. It's going to look for it. If found, it compiles to PYC. Right, so any import gets compiled into PYC, and then it begins. Then it's it's at the beginning of your code, and it's a PYC file. Otherwise, it's the standard Python file. And then the virtual machine executing. Having a PYC file saves you compilation time. So that's the final part of it. So we can move on from that one. That was a quick one, I guess. Not one I focus on really, to be fair. How is Python interpreted? So Python is a language that is not interpreted or compiled. Interpreted or compiled is the property of implementation. Python is a bytecode or a set of interpreter readable instructions. Okay, like crikey, those words are difficult. Like all of this stuff is quite like complicated word-wise. What happens in Python is it reads our code sequentially, apart from comments, all of this green stuff here. It reads our code sequentially in this order going downwards line by line. So it literally reads it like that. There we go. That's my arrow pointing downwards. We're reading Python code that way. And it's, I guess it's as simple as that for that part of it. But let's go on. I'll have to move that little arrow. I thought I was going to leave it on there because it looked quite nice. Python compile source code to the virtual example. Okay, the Python source code file is first compiled to give a PYC file, which is bytecode. The bytecode can then be interpreted by the official CPython. This is what nearly all versions of Python, I believe it's only 95% of Pythons are CPython, or the just-in-time compiler compiled by PyPy. But basically, when you write code in C, you have to compile it. And then you run the compiled code. In Python, it kind of like actually just runs through your lines of file and like reads them one by one. Now that's got advantages and it's got disadvantages. One of the disadvantages is if you had errors, it wouldn't have been picked up in the compiler. That's kind of like the key difference. But again, you should be debugging and making sure your code works at all points in times. Anyway, whether you're writing code in a compiled or not compiled language. So I think I skipped past that one relatively fast and painlessly. I don't know if anyone did ask a question on it. I won't get any further on the answers than that, without going into a deeper look at least. So question number 33, how are arguments passed by value or by reference in Python? Now that's a big one and an important one, right? Because Python, when I used to code in VBA, it had by val and by reference, and C++ and language like that, again, it has like pointers or by value, by reference. Now, like Python doesn't have that, but what it does have is it has the concept of mutable and immutable objects, which kind of like act in a similar-ish way to like by value and by reference, if you want to think of it like that. But pass by value means pass a copy of the actual object, really, is what it's doing. Like, and this is in all languages, right? You can either pass by value, which is I just want to get the value into my function. I don't want the memory address of where the value lives to operate on the memory. I don't care about that. I want to add up like 10 plus 5 in my addition function. All I want to do is look at the number 10, number 5. I don't care about their memory addresses. I don't want to affect their memory addresses, so I'm passing by value. And passing by reference is where like I want to pass something in, like an array in Python, or a list in Python, and I want to modify that list inside the function. Like, so then I will pass it by reference. I want a reference to that object, or I want to pass in a variable, and I will actually want to not just increment the variable, but I want to increment and give myself back a new answer. I want to increment the original variable in the code, like a counter for some reason, like a global counter. That's one reason where you might use global somewhere, the global keyword. So that's what by value and by reference actually does. And I wonder, well, here, yeah, they've got a nice, it looks like they've got an example. I'm not going to say a nice example, there's definitely an example there. So we'll go through that one. So anyway, by reference is reference to the actual object. Changing the value of the object will change the value of the original object. And that's kind of like the key thing there, really. I don't know if I can draw it out, like, as in function-wise. But by value, right, you know, we sort of like, you know, this thing here, I don't know, we got A, you know, and it does this operation. It doesn't change anything outside of here. Like it makes no difference. It's all inside the scope of this, and whatever happens, happens. So it hasn't changed the value of A outside of it. But if it was by reference, right? If we made, and I'll put that same A in, if we made changes to the A here, then it would go and affect this outside variable, like in this other scope. So that's kind of like the key difference between the two. It's a very subtle but important difference. So let's just copy this anyway, because it saves me typing out some code if I can. Here. And in fact, what I'm going to do, I can already see that I'm going to do this. Get rid of all of this stuff, and we will make our functions again. So I'm going to copy paste that piece of code in there, and I'm going to take all of this, right, because I actually want to show both of these really, which is this one, because this one is actually going to be the by reference, right? And one thing that I want to point out immediately is if I'm doing this and I like the function here sees that it gets this value, right? And it's we want it to be an array. It's called R because it's array, R for array, right? There we go. But Python doesn't know what this is, right? So it just assigns it to this value of any, right? But let's actually type into it to a list, right? There we go, right? And I don't know if you saw that, but this thing turned from white to yellow. Now it knows what it is, so it actually operates on it like a list. So I'm going to keep it like that because it's much nicer to do. And anyway, this one is going to be our by reference, right? So this is our pass. In fact, what I'll do is I'll write it in here. Right, pass by reference, not by read. Now it takes in what this function takes in this arbitrary list, whatever this list is, right? Here's our list here. We construct list 1, 2, 3, and then it does an append on this list, and it can return nothing. There we go. It will even return nothing, right? Now we create a list, and then we print our list, and that's going to give us 1, 2, 3. That's what at least it's inserting here. It's going to give us our output 1, 2, 3, and that's exactly what it's going to do. Then we're going to run the append list, and we're going to print our list. Now we are outside of the scope of where this array was appended. So you would like to think that the array is appended kind of like what we were all talking about before, which was like the local scope, the scoping, and the namespace, that it was inside the namespace. But I'm telling you, or like we're aware of mutable and immutable objects, and we know that the array is a mutable object, and we're going to get the memory address of it, and it's going to append. So what's actually going to happen is when we press F5, yeah, and it's already telling us there what we're going to get back, we have appended the value. So we've passed this effectively, this mutable object is passed by reference. Whereas if we did this one, which was, we'll do the same thing, append number. We can't call it append number, we'll have to call it something else, append single number. There we go, append single number. But this time we're not going to take in a list, right? We can take in anything, like an integer, right? Or a float, whatever. We can take in whatever we like, right? We're not going to do the append method this time. So we're going to do r plus equals 1. We're going to increment it by the value of 1. This plus equals 1 is the same as doing r equals r plus 1. Right, could have done any of them, right? Now we could even return it if we wanted to. But the point being is that whatever number we take in, it's going to increment it by a value of 1. And, you know, in theory, we could return array, right? Now notice we didn't return anything here. We could have returned the array as well, but it doesn't matter. The important thing here is that now if we do, so we can say r equals like 10, right? And we're going to append it, and what's going to happen, so we're going to do append single number, and it's going to take in, we see the type here, we've been hinted for an integer, so it's going to take in an integer. Oops, sorry. So let's just put in, we're going to put in this r, so we're going to pass in the number 10, just like, so look at the pattern. We've created this variable, we've passed it into this array here. Well, guess what? We're going to do exactly the same thing. We're going to take in this variable and we're going to pass it straight into our new function. So in both cases, we've passed these things in. And I'm going to make it look even more similar because we're going to do, right, there we go. Make it look identical, right? But this time it's obviously just going to output 10 because that's all it's got. Now, if this was to continue in the same vein, right, when we do our second print statement, it should output, or here's a question to everyone, if you're watching, like if you're live watching now, put it in the comments, but, you know, should it return 11 or is it going to return 10 or 11 ? So like which one's it going to return, right? That's basically the thing. I wonder if anyone does type anything quick enough. There was only one comment on this section, so you can type in 10 or 11 if it's too easy or too hard to do anything. But basically I'm going to run it anyway, but we're going to get back 10, right? So in the one case we appended something. That was his by reference, and I'm going to put here, this is by value. And the reason why is that the array, or I'm going to say list, because it's this variable r is actually a list. The list is mutable, right? And here the integer is immutable. There we go. So whilst we don't have a by value and a by reference, we can pass in mutable and immutable arguments and do that. Now you could ask the question, well, what if I wanted to mutate this? Well, there's two ways that you can do it. One is you can return array and you can pass back the returned value into here, into some sort of result, right? or we could say that R equals that. Well, that's mutated. That's mutated it. And what was the other thing that I was going to say about that? So one is you can do that, and two is the other thing is if you really wanted it to be mutable, you could pass this as a single item. So you could still pass it as a list, but a list of length 1. And then basically it would just be the first element of it, and then you could mutate it again. So you've got this by reference and by value construct in Python anyway. It just manifested itself in a different way. At least that's how I think of it. If there's any comments on that or anything you want to add to it, by all means, but that's kind of like what it means to me. So 34, what are iterators in Python? Well, we've kind of like gone through that one because we had the next, we already kind of like saw that over there. So an iterator is an object, okay? It's this thing that you can iterate through one item at a time. It remembers its state, i.e. where it is during its iteration, which was exactly like what we saw above when we were over here when we did our Fibonacci sequence. Like it's kind of remembering its state with this like yield keyword here, because this next thing, x.next, x.next, until we got to the error message at the end. We didn't a for loop, we didn't do it that way, but we got to the error message at the end. The iter method initializes an iterator. Okay, I think the difference is that the iterator lives inside a class, whereas the yield keyword lived inside a function. So the iterator is okay. It has a next method. Okay, so we can initialize it with this, and so it belongs in a class. This is our class array list, right? We initialize it with this iter method. I've not done that before, so I've not used iterators in classes, to be fair. I've only ever talked about them. I've not used them, but that's what that does. And then it has a next double underscore next method, which returns the next item in the iteration and points to the next element, kind of like a linked list in a way. Upon reaching the end of the iterable, the next must return the stop iteration. So it looked like our function that had the yield keyword. It just so happens that this one is in a class. It is also self-iterable. Iterators are objects which we can iterate over iterable objects like lists and strings. Let's just do it anyway. I'm going to again comment all of this out because, and we will move on to the iterator bit. So let's make a nice piece of blank space there, and we will get our stuff here, and I guess everything's going to be. Let's put this all in. I wonder if I have to tidy it up. Again, these modern editors are quite good because one thing they do is they get the consistency in the spacing and everything and do all the indentations for you. Whereas if you're doing it in the terminal, only like the true experts that can type at 4,000 miles an hour and remember all of the methods and attributes for all of their functions and are excellent with the manuals, they stick to the terminal. I'm quite happy sticking to VS Code or any of the other friendly text editors. But anyway, there's a class that's created. It's called ArrayList, and it's it's initialized anyway. What does the init function do? The init function is the first function in any class that ever gets run. So it's the constructor function basically. But thereafter, we see some other methods in the class. And this one here is the iter method, which we're told initializes the iterations. So I guess self.pos equals 0. It's remembering its state, I guess, return self. And then define next. It's going to keep on getting the next item. And finally, what would happen is you're either going to return your number, or at some point you're going to raise an exception, like so here you've got to raise stop iteration. So we, or at least here, what was done in the what we've got here is we've created an instance of the array list. We've passed in, because it's asking us to pass in a number list, and we could specify that we want this. We're expecting to get a list, although number list is a giveaway that we wanted a list anyway. So we're passing in this this list that goes into here. This number list, we just say self.numbers. So in our class, encapsulated in our class now, is this numbers variable, and it's been assigned the value of the numbers list. And then we can do the iteration on it. So it equals iter. So let's start doing the iteration of it. So we iterate. Let's have a look at what it actually says here, right? Iter on the iterable. The iterable is our list. So we're going to be able to iterate through our list object. Get an iterator from an object. In the first form, the argument must supply its own iterator or be a sequence, right? Well, we provided a sequence in there because we provided a list. In the second form, the callable is called until it returns the sentinel, which is until it gets to its final value, basically. That's the sentinel. Yeah, we create an iter on our array object, and then we keep doing the next function on it. And what's the next function doing? Let's have a look. If self.pos is less than len self.numbers, self.pos plus equals 1 return. Okay, fine. And I imagine it's self.pos. So the initial value of position is 0. And then it keeps on incrementing until we get to the end. So it keeps on going up like 1, 2, 3, and so forth until it gets to the end. And then at some point it would raise the exception. And I wonder, well, we got 3 items in this, it doesn't. But if we put in another one of these, I guess we're going to get the stop iteration thing coming up, because we'll have gone through one item that was index number 0. Then we're going to index number 1, and we're going to index number 2 there. So we're going to get our 3 items, and then it's going to look for something else, because it's going to go for next, and it's going to go. Well, it's just actually going to raise itself, because pos is now going to be greater than len of self numbers. It's going to be greater than that. So it's going to say stop iteration, I believe. In fact, it's going to, yeah, there we go. We've raised the exception. Okay, no description, but we've got a stop iteration, basically. So that's basically what iterators are in Python in simple terms. So it's in the class itself. Right, what's next then? Explain how to delete a file in Python. Okay, well, that's kind of like already there, right? But I guess this is a useful one, which is I don't delete files very often. I'm kind of like scared of deleting files, because I'm scared that one day I'll do a for loop and delete everything. In fact, I think I attempted to write a virus somewhere, and one of the things it would do was create a file and like make loads and loads of megabytes, and then the other thing it would do is sort of like go to a popular Windows folder and like delete like tons of stuff, like randomly delete files. But anyway, the bit that I want to say is again, we've got I can do import, and again something that comes shipped with Python is this OS module, which is the only reason why I wanted to have it there, because we can do OS dot, and we can see there's loads of things in here. Close, open, CPU count, I don't know, like a whole bunch of things. Look how long this one is, right? And there's lots of useful functions in here, like get environment, right? Get the environment variable. Get the current working directory. It's going to get one of these directories, the directory that we're working in, and so forth. So there's loads of useful stuff like that. But one of the things is we can remove a file, and basically it's as simple as doing os.remove. See, we can do read link, rename, but let's do remove tab, and then whichever file we wanted to remove. I don't want to remove any files, so I'll just leave it at that. But that is all we have to do. And a lot of these like standard things, moving, appending, doing this and all of that, are very, very standard in Python. Python's excellent at that. Python's probably one of the standout languages for that, which is why it became, it's one of its popular things. It's why it's known as a general purpose language. Those things are quite simple. Explain split and join functions. Okay, split splits and join joins is reality, but let's just take this here, right? Right, there we go. This is a string, right? So a string is a set of characters. The space is a character too. So there we go. And then we can do something like string. We can operate straight on these things. So string, and then dot, and it exposes all of the methods. So we don't just have split and join. We can capitalize, centerfold, count. We can do a whole bunch of things, lowercase, uppercase, check if it's numeric, right? But what was it? We were asked for join and we were asked for split. So split, right? What's it going to do? Returns a list. Okay, so we're going to get a list back from our split of substrings in the string using sep as the separator. So if I don't put sep as a separator, so I'll just do r equals. I think it naturally will assume a space is a separator. But we might have separators as like, let's say we had underscores in there, like in all of these. We could say sep equals underscore. But anyway, we can do print of r, and I think that's satisfactory for everything we need to do there. And look what comes down below. It split this out into this is a string. But actually, one thing that I should do is import natural language toolkit. This is AI stuff, but basically it's got a method that I wonder if it's even split. No, it will be tokenized, I think. I'm wondering what it is. I wonder if I get any of the methods. NLTK dot. Have I not imported? Okay, I may not have imported that package. No, okay, I haven't imported that language, but the all of the large language models, they do a better version of splitting now. They do something called tokenizing, and it will split it into other bits. It will actually recognize like the decimal, not the decimal, but the full stop means something, or an exclamation mark. Like it's much more sophisticated. But the basic split, basically a split this line up, and join will do something like this, which is, well, I wonder if I can rejoin, I guess. Because it joins the list back up, so I can do r.join. No, I can't do it like that. Or maybe I can. R is a list. I wonder if that will be sufficient. R.join. No, okay, fine. Let's just see the. Okay, it's like that. Okay. I take that back. I want to use it. We want to just use the join function. It's going to join our lists back. So it will be, but we have to say what we want to put in the spaces between. So let's just do this, for example. This is quite nice because we were just talking about it. Dot join. So that's our method, and then we want to join our. So what's going to happen is we're going to now join all of these things. This is a string. But we're actually going to join them. Instead of putting spaces in between it, we're going to join like that. And then we can put like our new result. So we call it R2. Okay. And then we can print R2. So join is a reverse of split. Split breaks up a string. Join can join it back in. And we can do a whole bunch of other things with it as well. Let's just hit F5 to run it. and now we've converted it into this underscore is underscore a underscore string. Now we could do more than that, because we could use the you know, I didn't have to do it in that way. That was just because that's what the question asked, but we could do string dot, I think it's replace right there, and we could replace what we want to replace, so presumably like a space, with a underscore, and we could call that R3 and possibly print R3. There we go, and run that. So they're just two of many, many functions. You know, we were able to split our string up, and we were able to join it back. Where do you use these things, right? Quite a lot of things. It's like where you've got text, and it's coming like in a CSV file, and you're sort of like reading it, and sometimes you want to like put them together because it has meaning together. Other times you want to break them apart, or you want to like take the first word or extract something from it. You might use splits and joins for things like that. Replaced did both of them. It like took one out, put one back in. There's tons and tons of functions on strings. There's just two of them. So that's its simple version of it. Now this one's a bit harder. So we're going back into the hard stuff again. Kind of like don't like to go into the hard stuff, but we will do. What does args and keyword args mean? Let's start arg and keyword. Basically, so args is a special syntax used in the function definition to pass variable length arguments. Star means variable length arguments. It's also the unpacking operator. So basically, and args is the name that's used by convention. So it's something like, well, I mean, this function kind of like sort of like told us everything we need to know, so I'll take it. That's quite helpful, just like that. If I comment again everything out here, and I go over to this, and then let me just get all the indentation correctly. What this is actually saying is, I've got this function, and normally we say let's pass in A and let's pass in B. We know exactly what we want to pass in. But actually it's saying like, well, we don't know exactly what we want to pass in. We want to actually pass in a few bits more now. So, and I'm going to do R equals this multiply because it's a little bit cleaner and it's print out R at the end. R, so it goes like that. So our multiply function now takes in A, takes in B, because we can see that those are the two things we're going to do, and it's going to multiply for num in arg v, right? So let's have a look. Multiplication equals A times B, but then we're going to go through this arg v, and like it could be any length of arguments. We put in 3, but we could have put in more. So let's just run this piece of code, right? So that's 120. So this star args is really convenient because we can do this, right? It can be any length of arguments now. We don't have to have a fixed length of arguments. Again, I'm not sure, anyone who's watching this, if like a language like C++ offers it or not. I can't remember if it does, but if you can put in any number of arguments in a way like that. But Python offers this, which is quite nice. So it offers the star args, which means you can keep putting in things, as many as you like. So again, run it. There we go. And after that, then it's given us back this big number. We could put in a list of any size basically into here, or any number of arguments, not a list of any size, but any number of arguments. Now I tend not to do that because anyway, I'll pass in a list. If I wanted to do it, I'll do it via a dictionary or any other ways. So I basically barely ever use the star args. But the other one is the, let's go to it, is the keyword arguments, which is the kwargs. So you've got the args. Now let's go and have a look at the kwargs. Which is the keyword argument, which is basically, let's have a look here. Okay, it's a special syntax used in the function definition to pass variable length keyword arguments. Here also kwargs is used by convention. So it's common in Python, but it just stands for keyword arguments. The keyworded arguments means a variable that has a name when passed to it. So it's actually a dictionary of the variable names. So basically, I think I want to get a better example of it. So what I'm going to do is example of keyword args in Python. It will know, the large language model will know what this is because it knows what kwargs are. Sure, I can tell you what kwargs are and how to use them, because this example wasn't the best one that was here. I'm hoping for a slightly better one, although I got the same bog standard argument, so not great. But anyway, let's take it, which is this over here, and then go to our VS code. That was our args. Now this is our keyword arguments, our kwargs, and here we're literally specifying things, so we're saying what goes in here. We could actually pass in, and this is the thing, we could pass in a dictionary, but this could be of any length, so we could keep adding things in here. So I'm just going to do this, F5, because it already does it, and it's going to print out all of our keyword arguments. So it's going to print out name, and it's going to do this, right? This print args takes in this whole value stuff, whatever's in here, and it's going to go through each pair one by one. So this is the first pair, name equals John. This is the second pair, age equals 25. This is the third pair, city equals New York. It's going to go through them one by one, and it's going to print them each time. It's going to print the key, and it's going to print the value in this format, in this F string, right? So here it is. It's printed John, age, name John, age 25, city New York, right? But let's just do like, we don't know how long this is going to be, so like, you know, it's sort of like we want to get his hair color, right? And he's got brown hair, right? And then we run our piece of code a second time, and the kwargs works like a treat. Now, you know, why do we not need kwargs? Because basically I could do something like this, which is I could say d equals dictionary. I'll construct the dictionary like this because the reason why is I know that I'm going to steal all of this stuff straight out of the dictionary and go like that, and so that'll make it look even a little bit cleaner now. There are places where you would use args and kwargs, but I tend not to need to do that because basically I will then, because it's all about the structure, right? I will make another like function which is print args, print new args, right? But this time it actually takes in a dictionary. D is a dictionary. There we go. I'll even type into a dictionary because that's what I'm expecting. My dictionary can be of any length. I can add and append and do what I want to the dictionary, and I can do exactly the same operation, which is for key and value in the in d dot items, right? So I can do exactly the same thing. Print. I'll do the F string of the key and the value, right? And so in one case I've like passed, you know, whatever variables I wanted in there, and the other way I have actually constructed the dictionary and passed the dictionary in. You could argue they're the same. Say, I don't know, sometimes you might need the args and kwargs version of it, and it prints out exactly the same stuff. So that's what it's equivalent to, at least. That's what args and kwargs are. So I'm going to say that one's covered. And this is the final one, right? We're on the final question now. So what are negative indexes and where are they used? This is quite a nice one. I actually covered it in the last session because we just came over it for some reason. But like basically, what are negative indices and why are they used? They're really useful actually. When you want to be like super lazy, Python offers you negative indexing. So we've got this list, right? I'm going to steal a list that they've got here. And I'm just going to change this list slightly because it's nicer when you do something like that. Right. And it talked about like slicing. What is slicing? You know, we could get like parts of a list. So we could do print and then array. But we wanted to print the middle of the array, like 2 element, like 4, which is inclusive and exclusive. So it's going to print the second element and the third element, but not the fourth element. And this is the element 0, 1. So this is the second element. This is the third element. So print 30, 40. That's what this will give us back, right? And when we run our piece of code, it gives us back 30, 40. Fantastic, right? But let's say we wanted to print just the first element. Well, that's easy enough because it's element number 0, right? F5, right? Great, fantastic. We got 10, right? But let's say we want to print the last element. Well, it's not too much of a problem because basically we could print the array and then we could get the length of this list and then we like however long R is, right? That's the length of it. So it's going to count. It's going to go 1, 2, 3, 4, 5, 6, right? It's going to print us back the 6 items. So let's just do it. Okay, maybe I have to pass it in. Let me hit stop there. Because I've got to do -1 because it's going to be 6 and it's going to be. I thought that was going to throw that error, and I was going to put it out explicitly, which is size is equal to this, right? The size is the length of the array. This is going to be 6, but the last element, because it counts from, we start counting from 0. This is not element number 6, this is element number 5. So 0, 1, 2, 3, 4, element number 5. So we've got to take off 1 because it's going to give us back 6 minus 1, which is 5. So we're going to put the size basically. So we could do something like this, right? Now, it's not too bad. We got it, we got number 60. We could have said, well, let's pass this whole length thing in here anyway. We didn't need the size thing out of it. So there we go. And we could delete this whole line if we wanted to. But that's quite a faceful and a mouthful, isn't it? Like, that's really annoying to have to do that. Well, guess what you can do in Python? You can do this. Print array -1. There we go. And when we do that, we also get back 60. So what's actually happened? Well, this is element number 0. This is element number 1. This is element number 2, and so forth. And then it goes all the way ... And this is element number 6. And that's counting forwards. We love counting forwards, right? But Python lets us count through the lists backwards as well, which is great because then we can go element number -1, element number -2. We get what's happening, and this will be element number -6 basically. But notice one thing. Oh, sorry, this one here was actually 5, not 6. I'm going to be careful about that, right? Index 5, not 6, right? This goes from 0 to 5. This one, when you count backwards, it goes from -1 to -6 because there's no concept of -0. So that's the only one thing that you have to remember, but that's quite logical. So I think that covers it. That's what negative indexing is, and you can also traverse through lists negatively as well. So you can sort of like step through it. But we did that in the previous session. So that's basically it. We've come to the end. This was the end of our session of Python interview questions for experienced users, I'm going to say. And I guess the next session, which is already the one down there, which is Python. Object-oriented programming. I don't know what the S stands for actually. What does the S stand for? Object-oriented programming interview questions. So basically we did an advanced version of Python, and I'm going to sign out here because it's got to the 3-hour mark. Okay, I've done 3 hours. It's way too long. If you like, or please, even if you don't like, hit the like button. Even if you hate me, subscribe, because the worst thing that can happen is you'll get a video once a week or something like that. It's not the end of the world. Subscribe, like, follow, watch, switch it on, watch it in bed. That's what I do. I watch lots of Python videos in bed, And that's really it. Any questions, any comments, put them in the chat. And that's it. That's our advanced questions for Python, or whatever it's called, Python interview questions for experienced users. The end.